everybody, and welcome to the 2026 International Rocket Engineering Competition brought to you by the Experimental Sounding Rocket Association. We are about to launch our first rocket. From the University of Laval, Quebec, Canada. To all our viewers out there, we just want to give you a heads up from the live stream team that due to geographical interference, we will not be able to catch part of the launch from our angle, but we're going to try and capture everything that we can. Thank you so much.
Paulo from 309, next up. This is his 10K flight on N Supermotor. University of Sao Paulo from 309. They are on Tuesday pad 1.
Yes, please.
Sorry. Come up, that's where they're going to be. And we are going in 5, 4, 3, 2, 1, liftoff. We have liftoff. Oh!
282. I'm sorry. 149.
I don't know if that looks good.
I'm so sorry, guys. You're trying very hard.
Okay.
You
Yeah,
have
if
to
you don't mind,
go.
if
You have to
you'll
go.
let me. Yeah.
Well, it's just a bummer for these teams. No,
It
and
is
they've
on
done
the
the launches
day.
out and they're looking at commentary. Just to say, like, congrats to them.
Thank you guys so much for your patience.
Okay.
He's not. Good. It's a delay.
Yeah, that's the tough part.
Not right now. See how much this is going to go.
And I shouldn't. The guy we did yesterday.
Dwayne?
What point? Yeah, now I remember. I showed him the books that just had a bunch of fires. He said it wasn't his. General books that fires like fire. He said it's not his. It's not yours.
It's not his. It's not mine.
It's good.
All right, I'm going to need you to start getting me video comms through the headset. So I know where we are. Okay, because I have a latency on my end. That's video. Yeah, that's the order for solids, A through. Yeah, you may have to reference your text though. Okay, do we know if 209 is actually scrubbing? Or is 209 good? Are you good at BSing?
A little bit, yeah. I'm a professor, so of course.
All right, I'm going to... Yeah, we're going to go live in the commentary area. We have a Hi everyone, and again, welcome to the IREC. I am Jessica McCarty, the Media Director here at the Experimental Sounding Rocket Association, and we also have
Charlotta DeVries. I am from Rowan University. I'm my Rowan Rocketry's faculty mentor.
Right.
And hopefully you can hear us. We're checking on the chat to see if you have anything. But of course, our internet is a little bit delayed for what we can see, so there might be a little bit of a delay there. So hopefully we see some positive affirmation that you guys hear us. They say we're back. Awesome.
Oh,
Thank you so much.
awesome,
Those
awesome.
comments really help.
All right, let me confirm. Who's up next to my team? Or is it two? Okay, up next is team 209. That is Brigham Young University.
Oh, these guys have a wonderful rocket. I'm also a volunteer judge. I got to see their rocket yesterday. Incredible group of engineers, and they worked so hard, and their rocket was just incredibly well done.
Awesome, awesome, awesome.
Oh, and we're on the video.
Yeah.
And you could see me striving to read the comments.
This is not our day job.
Yes, someone had the comment that streaming audio is not rocket science. Unfortunately, we have rocket scientists here, so it's going to be a little bit harder for us. Everyone's got their expertise.
All right, guys, we are having some telemetry lock issues, which we were expecting. So things are going to start moving a little bit slower as we get those locks in place, because without telemetry lock, of course, we can't fly. Yes. Tell me about telemetry lock. What does it? How does it help the students, the rocket?
So the telemetry allows the students to track where the rocket is, where their GPS.
I'm sorry. Team 402 is next. I'm sorry that just came through. We are actually getting flight. They're locking on telemetry now. 406 is the University of Washington, Seattle. University of Washington, Seattle. I'm sorry, can you please finish that conversation?
The rockets need to have a way to communicate with the students' ground stations and their home computers to say where the rocket is, so that they can use their assigned frequency to track where the rocket is, so that when they need to recover it, it's going to be a decent hike away. So they need to be able to find their rockets at the end of the day. So that's part of the reason that we have the telemetry. And it also lets them know everything's going according to plan, so that you shouldn't have things like,
all right, we're at launch.
We're going.
We're at
awesome.
Launch. And we have liftoff. I wish you guys could hear our media team in my ear.
So we have a little bit of a delay, but from the sounds outside the booth, it sounded like things went really well.
Team, can you give me another update? Oh, that is an amazing
That
flight.
is awesome. Oh my goodness. Wow. That's gorgeous.
Congratulations, Brigham Young University, on an amazing flight.
Is that Brigham Young?
Mm-hmm.
Okay. Wonderful. Yeah, so they're attempting to fly to 30,000 feet today. And so you'll have different competitions that the students are going through. So it is 10,000, 30,000, then 45,000?
It is correct. That is correct. That is correct.
I've got the experience with the 10,000, 30,000 because so those are the ones that I know. There are also going to be some demo flights of students who are going even higher or having something special to show.
So they are, of course, tracking the flight. You can see the drones are headed back towards the solids pads. We're still waiting to hear what team is going to be up next. Oh, we have live video.
So this is where students are sending packets from their rocket, and those packets are being able to be transmitted to a student's computer, which is fed into the HDMI to the YouTube live stream. This is usually the most significant draw of power that a student would have on their rocket. just to get this image to us so that we can see it.
It looks like they are looking at the rocket. To our YouTube audience, we are watching this with you, so please bear with us on the commentation portion. And if you have any questions, please send them our way.
Yep. So yeah, someone was asking, when are different teams launching? And the category is first come, first serve. So students were in line at 5 a.m. this morning, and some of them had over a 2-hour drive to get here. Then it was the first ones who were ready. There was the Salvo video, which was the first Salvo was the first batch of students, which are the ones we are seeing right now. These are students who were ready yesterday. They had their clear through their safety review. They finished their final safety reviews this morning and showed that those rockets are ready to fly. And then they need to wait in line for everything to work well, because sometimes you'll have a rocket that gets to the pads and something won't work. The students decide that they're not quite ready to launch, and they'd rather have a safe and successful launch than a rushed and early launch, which is always a wise choice to make. So as a result, we do not know when teams are flying, but you have an idea if you're contacting loved ones on the flight. Once they've gone through that final safety review, it still might be a couple hours before they launch.
All right, so next up we're going to have Team 405, which is a 30K SRAD solid motor from the University of Minnesota, Duluth.
Wonderful. And so SRAD, if you haven't heard that term before, means student research and developed. And all of the rockets, whether they are custom off the shelf, oh, we got the launch coming.
All right, we have a launch coming. We're going to quiet down so you guys can watch. We have had a hold on the launch. Just a minute.
Still says mic volumes are too low for some people. And someone else said it was too sensitive.
Who can you hear? Can you hear Jessica or can you hear Charlotta so we can know which mic's going bad, please?
So I am Charlotta, and you just heard from Jessica earlier. You can only hear the two ladies. That is correct. That is the people that you would be hearing, because that is where we have the audio.
So the launch, our parabolic mic for the launches is actually having issues.
So we're waiting for University of Minnesota Duluth right now. And as you might have heard, or maybe not, because we heard we had some microphone issues, this is an SRAD motor. So SRAD means student research and developed. So this is a student have gone through, they've designed and created their motor from scratch. This is in the solids category.
It is?
It is in the solids category, which means it is a solid motor as opposed to a liquid motor, which you'll be seeing later today.
So currently all the teams on this salvo are solids.
Mm-hmm.
We are not currently watching hybrids at this time.
Okay.
The very first rocket to go off today was our first two-stage.
First two-stage.
Yes.
And since usually the track has just covered the first part of the launch, do we know that all of these launches have been successful, or have we not heard how they did?
So the first two, to my understanding, successfully landed.
Wonderful.
The last one that we did have, there was a question on whether it came in ballistic.
Okay.
So we currently do not know the status of that particular rocket.
And so coming in ballistic means the main did not deploy, so it came in too fast.
Exactly.
That happened to my students last year. It is a devastating thing, but there's still a lot of work, and just getting that successful launch is such an achievement. So hopefully their rocket is okay and that it landed nice and safe.
All right.
Do you know
So-
which team that was?
Not off the top of my head.
Okay.
All right, so it looks like we might be seeing team 402 next. I'm sorry, please forgive me. We are doing team 405, the University of Minnesota Duluth. We are actually currently waiting on an EMS truck to make sure the scene is clear. I am going to be quiet now.
So outside, they're saying it's a 30K. Try to get that audio out there for you.
We have a green light on the pad,
They have a green light on the pad, which means it's going to launch.
and we have a clear sky in the air.
Clear skies in the air. And we don't hear a countdown here either, so that's why we're staying quiet to try to listen for it.
All right, we're heading down west on the road, so we are clear to go. So we are on Charlie 2 now, 30K yes rad. University of Minnesota Duluth, going in 5, 4,
5, 4, 3, 2, 1.
And it looks like the igniter burned, recycle. Looks like we burned the igniter and no ignition. We have no continuity.
So we are talking to the commentary. We're seeing the video a little bit. I have a new guest with me. So Rick Willis is with me. He is the liquids lead. So he can tell you a little bit more about liquid launches and what is happening there.
Well, right now, these are the All right, can you hear me? All right, we're live. We're live.
Okay. Well,
We're
hello,
live.
Rick.
Hi, Charlotta.
So we are here. If you were watching 405, they had a igniter that didn't work. But now we're going to switch to Team 32 because they are about to launch. That is Liberty University.
Liberty is also in Virginia, too.
Is it? Nice.
And I'm trying to see where's the rocket in
So
that
we're going to
shot?
see a huge delay on our screen.
Oh,
So
okay,
right now we're trying to see the
okay, we have
thing.
a
Right now,
screen.
our view is the Texan desert, but we're listening through our headphones so that we know what's going on. And so we can hear the outdoor speaker, and that way we can reiterate to you what's going on. So we're waiting for Liberty University right now.
Liberty's a single stage. I think they're 10K.
10K solids.
10K
So we're all
solids?
solids right now.
Yep, this is
And-
the solids pad.
Yep.
Oh, there we are. Hi, guys.
Hello. And
We need to put that screen over here.
oh yeah, that would be helpful.
That would be helpful.
So
So here we are in the western Texas desert, just south of Pecos, between Pecos and Sargasso. It's probably around 90 outside right now, going to 105, they tell us.
I saw 108.
108,
Maybe,
all right,
maybe,
8.5, that's pretty.
yeah, at
pretty
some
close.
point you just want to be inside and
Drink lots of water.
drink lots of water. Yeah, so hopefully if there's students who are watching this from their hotels who aren't yet launching here today, they're coming later, make sure to start drinking early. If you're here today, when you go home, keep drinking water, make sure to get some electrolytes with it.
That's right. That's right.
and-
Drinking water, the purpose of this is that you don't have to, you're going to be sweating a lot, and the water you use is going to, you have to keep refilling it. Don't gulp it down, sip it down.
Sip it down.
Sip it down
Yep.
slowly. And that's probably, oh, there's somebody just took off.
Oh, so Liberty did take off. That's a huge delay. But that's exciting for Liberty.
That's Team 32.
Oh,
Which team
oh,
is-
we've got some
Oh,
issues here. I think,
we just fixed, how'd our thing fall down? All right.
okay,
Get a
so
little
we're
better.
having some technical difficulties over here. So rocket science is much easier than audio science, as you keep saying in the comments.
Media, yes.
And
There's a
media
good
science.
example.
So,
So right now we're in a Salvo situation where we're launching a bunch of solids went out there, solid rocket propellant. They loaded them up. Now they're going to shoot them sequentially. So it should be every few minutes we should be shooting one. I believe this is your first IREC, isn't it?
it is my second IREC. It is
Second
my first
IREC.
IREC as a volunteer judge.
Okay.
So I got to see a bunch of really awesome, I got to see 8 really fantastic teams
Yes, so
in
did I
the
yesterday,
30K
yeah.
cuts. And last year I was there to watch my team Rowan University launch. And
Now, are you on faculty there?
I am a faculty
Oh,
there,
what do you teach?
mechanical engineering.
Oh, I'm at the faculty at University of Dayton. I teach mechanical engineering.
Oh,
as well.
nice.
I mean, I'm an adjunct. I'm not a full-timer. So
Yeah.
I don't envy you full-timers. I'm retired from one job. This is just a part-time job.
We have a lot of very happy adjunct retirees who
Yes.
just do it for the love of the game, and I think the students
It's
always
fun to
love
come
that.
back and,
Yeah,
there's certain classes you like to teach, and that's,
and the students love having faculty who have industry experience and
Uh-huh.
are able to share stories of what they've done in the field.
and that's one thing about being 70. I'm 74, so I've seen that the computers weren't around when people did drawings boards, so it's been a change. This is at the level that 30 years ago would have been considered at the military level. It had been high grade commercial
Yeah,
or high grade military. Now we're doing it as this is a hobby.
yeah, which is
And there are a
pretty
lot of
exciting.
schools that are sending people to the big aerospace companies like Blue and SpaceX. So.
Yeah, we saw them at some of our sponsors that were here at the competition.
Yes, SpaceX
And,
is a sponsor.
my
Blue Origin.
Blue Origin, my
Yeah.
students were all very excited that they were accepting resumes, and so it's a wonderful opportunity for our students.
There's another shot of the pad, and basically, we are on a delay.
It is just it's a long delay. So how long have you been working with IREC?
I have been working on that since 2014.
2014. So is that when it started?
It started in 06 or 08,
Okay.
and I didn't come till 2014. The reason I came was I have been doing liquid since in the late 80s, and they had a liquids team coming, and nobody had any. So Matt Ellengold, who was working with Paul at the time, said, "Rick, would you help me?" I said, "Sure." And this is in Green River, Utah. So I went out there, and there was a liquids team, and they weren't able to fly. They had some challenges, but that was the kickoff. But interesting enough, the first team that won the Spaceport America Cup is where we came from. Was a liquids. University of Michigan won as a bipropellant liquid.
Nice.
So liquids have a long tradition here. So next year we're expecting to have a lot of liquid, or at least I'd say half a dozen is the max. So that would be fun.
Yeah.
Right now we have, I believe, 8 hybrids. So those are hybrids and liquids are very closely related. You just have to add fuel.
Can you explain the difference between a hybrid and a liquid?
Liquid rocket is bipropellant and has 2 liquid oxidizer and a liquid fuel. For example, liquid oxidizer could be nitrous oxide. We'll just pull that all the way down, make a decision. There we go. Okay. So the liquid oxidizer is going to be, and of course liquid oxygen is another liquid oxidizer. The fuels would be typically isopropyl alcohol, kerosene, things like that. So the hybrid has a liquid oxidizer, typically nitrous oxide, N2O2, about a third of its oxygen, and then you have a solid fuel grain, which is typically made of a plastic, wax. There's a variety of different solid fuel grains, and you feed that nitrous oxide into the solid fuel grain to burn. So in the liquid oxygen, bipropellant, you feed the oxygen and the kerosene in together to burn in the combustion chamber. So it's a little different. And there's a new liquid oxygen, or a new liquid rocket called the Mojave Sphinx configuration, which uses nitrous oxide as the pressurant, and it pushes a piston on the fuel to push the fuel out. So that's very simple. There's no complex. Oh, there we are. We're sorry, there's a delay going on here, so we're looking at what we used to be talking about. So the nitrous oxide has it's able to pressurize itself, and that's a very useful characteristic to have. So that's what the Mojave Sphinx. The Mojave Sphinx guys are half-cat rocketry. They're in California, and they're both the 2 guys that did it are very experienced. They're level 3 rocketeers. So they're professionals. They're aerospace professionals in the field. So they said, "Hey, we can build this." So the great thing is they gave it away. You can go at the half-cat rocketry. You can get the book free. You can also buy the book. I bought it for $35.
Nice.
It's about that big. So but it's a great book. It's about inch thick. Everything is in it. You can build one for under $2,000 is what they're claiming. But there's a lot of support equipment you got to have too.
So what sort of L1 certification do you need, or L certification do you need from
Right
Tripoli?
now, the certification in Tripoli and National Association of Rocketry are at how much a total impulse is. It doesn't have to do with the propellant type.
Okay, so you could do like a small scale
So
one?
you could go with theoretically, you could go with an L1, which would be
Oh, we might have a launch coming.
okay.
Could you please repeat who's launching? No.
Okay.
Do you
So
still
the,
have audio feed on your
Yeah,
headsets?
I think so.
Okay.
No one's talking. Is anyone talking right now?
I don't hear anyone.
I don't hear anything either. Okay. So the L1 is if Tripoli has typically, and NAR has typically said, what are the total impulse? And that's the standard you use for a level 3 has to have like a higher impulse than the level 1. So that's everything. The level 1 start at the...
Okay, we've got University of Washington, Seattle next.
Okay. UW, the Huskies.
University of Washington, Seattle is about to launch.
Thank you.
Thank you.
Here's one. I have more coming.
Oh, thanks.
We need to put that up with...
Pins or something. The
pins.
wall is just not sticky.
Or Velcro. Get some heavy Velcro.
Yeah.
That would keep it up.
Well, we tried using command strips and that didn't even work. So
It's just heavy. Come on, it's just heavy plastic. What are you looking for? Oh, it's. Oh. Are we up? Somebody
I
else
can't
is
hear
on?
anything on my mic.
Are we live?
I can't.
You know what I want to do then? I want to get the other hotspot.
Okay.
Okay.
So we're on a little bit of a delay. We're looking at some rockets on the solid stand. So you were the judge for the 30Ks? How
I
many?
was judge for 30K solids.
Okay.
and
How many were there?
I don't know how many there were in total because judges get up to 8 teams.
Yeah, eight.
So
yeah.
I judged 8 teams, and I think there might be. It's a lot smaller than the 10K. So the 10K we
yeah,
have
sure.
over 100 teams started, but not everyone makes it from starting and getting a number to the competition. So along the way, students might come into funding issues. They might
Yes.
have that their rocket is not safe enough or they're unable to make one. Okay, we're getting.
406 Bravo 1, Vandal, 10K Estrad, M1608, Purple, Bravo 1.
So we are looking for Bravo 1 on the launch pad, which I believe is University of Washington, Seattle. 4, 3, 2, 1. They have liftoff. That's wonderful.
Liftoff, okay.
Oh, that's always such great news
So
to hear.
we're in the sky.
Oh, wonderful. You can hear the students outside just going nuts. They're so happy, so excited. Hopefully, hopefully we can get some shots of the students in a bit. But
And if you
absolutely
don't know,
wonderful.
there are a huge tent right out, literally 50 yards away from us. There is a huge tent full of the student teams that have all their test equipment, their telemetry equipment, and they're watching it. So you hear these yells and screams.
Okay, next up we have Brigham Young University.
BYU.
I mentioned earlier that this was one of the teams that I judged. They have a beautiful rocket. They did a wonderful job. They did some cool testing for, they have these very incredible machined aluminum fins, and they had these bolts. So one of their podium presentations, because it's also a bit of a research talks that we have yesterday, they have a cover to decrease the drag that they tested within a wind chamber. They're about to
And
launch.
BYU has flown here before. They've been flying here probably 5 years at least. So
Yeah.
they've had a long history of being here. So yeah, there are a lot of. I'm surprised how many schools have been here more than a few times. There are many seniors that I've talked to yesterday that this is their 4th IREC, so they have quite an experience. So this is a good experience base, and those are the schools you can see have learned
5,
a lot of lessons.
4, 3, 2, 1. This is Brigham Young we're waiting for. Brigham Young University. They have liftoff. You can hear the cheers outside. Oh, you can hear the rocket too. That's beautiful. Oh, absolutely lovely. And so they were aiming to go to 30,000 feet with their solid rocket, but pretty much the rest of the rocket, so much of it was student research and developed. So when you hear COTS, it means custom off the shelf, which means they purchased their motor as opposed to create it themselves.
Yes,
but there's still so much of the students' research and design.
there's a lot of structural design that has to go into a rocket that's going to 30,000 feet.
So next up, we're going to have Buenos Aires, University of Buenos Aires. Also a gorgeous rocket, one of the sharpest nose cones I've ever seen.
Oh,
So
really?
yeah,
Oh, okay.
it was absolutely a piece of beauty. And okay. Sounds
BYU
good.
may have had an event.
So we are waiting on Buenos Aires, and then we're going to have another guest come in, and I'm going to rotate out, And I hope you enjoy watching more of IREC. I hope all of the teams that you love and care have wonderful launches and do the best. But sounds good. Okay. Well,
Okay.
I will see you all later.
Take care. Thank you for coming.
And we'll lift off. All right, next up, we have another 30K shot. This is École, technologie, supérieure, with 3400 IMAX, with 30,000 feet. Hold on.
Two 1-9. 219 is a they are from Quebec. They are in Montreal, and they're flying I think a 10K concert.
219 on the pad. 10K cots.
École de Technico supérieure.
Appears to be green. 2, 1.
Ignition.
Let's see some smoke. We got liftoff. Excellent. They got a good track. That's sounding good.
ETS is in the air.
Always good to hear clapping when you see a launch like that.
It's enthusiastic.
Excellent CR.
What's the temperature out there now, Andy? Do you know?
It's well above 100, I'm sure. It's going up to 106, I think, today.
106. Yep. 10 o'clock
Next
of the night.
launch.
So it's
Oh, excellent. Alpha 4 pad is next, University Technology, Malaysia. So, great to have a Malaysian team here as well. Pad Alpha 4. Going early salvo is always a good sign. That means the team was very well prepared. They quickly made it through their inspection process, and being able to go in the first salvo is fantastic.
and it means the rest of the time they can just sit around and watch.
That's true. They help out other teams.
Yes.
I'm sorry, did they just launch?
All right, we have a green light on 4. And we have a clear sky. So we're going in 5, 4,
Right outside our window, we actually have the launch control people and the people flying the drones 30 feet away from us. So we're lucky. We're inside of a nice air-conditioned room where our friends are outside sweating.
We don't get to see exactly what's going on there. We do have a video feed here, but it's delayed, so we are kind of handcuffed a little bit. It sounds like we had a CATO on the pad, a catastrophic takeoff event. Motor overpressurizes typically, and
Blew apart.
so a lot of different reasons for that. When you're preparing your motor, could be anything from a manufacturing defect, if it's a commercial motor, to a situation where the motor wasn't built per specification, or if it was an SRAD motor where they were mixing it up themselves, potentially the building of that propellant may have had a small anomaly, a big air bubble or some form, and so the cases are designed to fail before actually completely destroying everything in sight. So there are some contingency plans in the development and design of those motor cases for the SRAD cases.
Remember what SRAD means, Student Research and Development.
Correct. Student Research and Developed, which means they pretty much designed the propellant, they designed the case, and they had to build it all themselves. And that also means that they had to test fire that motor, typically at least once successfully, if not multiple times successfully. And they usually start in a smaller scale version of it and build their way up to a full scale production. But before they launch here at the IREC, they have to provide proof of a successful hot fire, including all of the data and the video. So we still get a fair number of CATOs.
Yeah, we still do, sure. Well, even at, I was at the major high power rocket tournament in LDRS in Indiana, and we saw some CATOs there too. So
Sure, absolutely.
So do you mix your own?
I do. I actually do. I haven't done it in a while because I'm focused on ESRA a lot, but I do have everything I need down in my workshop, and I enjoy it. It opens up an entire new pathway of interesting steps.
I've never mixed composite. I've mixed sugar motors.
Okay.
I have a whole setup now. I have an oven I put it in so I can control the temperature very precisely. So it makes life the pot life is a lot better. Now you have a big mixer, don't you?
Very good. Yeah, 25 quart mixer, a Hobart that I got off of somebody that was getting out of the process and donated it, and used it for a lot of different clubs to help them get started. So it was quite exciting. Had a young student who wanted to learn a little bit more about it, and so we started the mixing process and explaining all the chemistry to him. And he was an advanced chemistry student, and so he turned around and goes, "Oh, that all makes sense now." And I'm like, "What are you talking about?" And he starts going into molecular breakdowns and how they combine and break
and
apart.
Combustion change, yeah, that's
and all of
another thing.
these
Yeah,
things. And he went right over the top of my head. And I was like, I trust you.
That
I'm
happens.
sure
That
that's
happens.
how it works.
And you moved recently from now you're in Raleigh.
Yes, that's true. I'm in North Carolina and just moved from Texas. So
Okay.
a little cooler, but a little harder to find launch sites. That's true.
Yes, that's the truth. That's true. Well, I have an advantage. My three sisters live in Raleigh, so when I come visit them, maybe I'll call you up, take you out, you and Bet. And your wife isn't here this year, is she?
No, she's not.
She's
She
not.
she threw her hat in and said she was retiring from
That's
it.
right.
The heat was a little too much. I
I
don't blame her
understand
one
that.
bit on that one.
Well, his wife did a great job. I mean, your wife,
No, Kelly.
Kelly.
Yeah.
Kelly did a great job. I remember she ran a good ship when she ran it. So I was tell her service was well appreciated.
She's always is an organizer, and if you can imagine the move from
Sure.
one state to another,
Yep.
it was very well organized.
Yep. Well, Raleigh's a nice town. I've been there a bunch of times. It's a nice town.
Yeah, the area where we live near Hickory had its first 90-degree day.
Oh, really? Okay.
Like a week and a half or 2 weeks ago. And in Texas, where we were living before, we already had several 100-degree days. So I'm enjoying it a lot.
Yep.
Looking forward to actually getting back pretty quickly too.
Well, the accent's a little different too. You got to get used to that.
That's yeah, not too bad. Everyone's very nice there, that's for sure. All right.
Well, it looks like we're in a lull now. We aren't firing. There, what you're seeing, teams are going out now to recover their rockets.
Yeah, and actually, I'm a lot more focused this year in the recovery space. So we have a very detailed process, as we typically do every year. But in years past, we had an organization known as Da Vinci Maker Labs, who would manage all of our recovery teams for us. It was quite nice. They did a fantastic job. And they had to step out. They had to refocus on a couple new priorities, and so Esra has had to pick up the responsibility for it, and so we're tracking the students as they go out. We're ensuring that we have communication with the teams as they're out there the whole time, and we also highlight, you've been out there too long, you must come in, and also tracking them GPS-wise to ensure they don't accidentally go into a potential recovery area with rockets raining down on top of them. So that's really the key focus on it, and we've partnered with Motorola, and if any Motorola folks are out there, we'd like to really commend them on their TLK 100 system and the Wave software, and feel free to contact us, because we would really like to spread the news even more about how fantastic the software is. And so far we're using about 8% of the total functionality, because we're just learning it as we go, and it's amazing stuff. And it's going to be a vital tool for us in the future. So anyways, the students have little handheld radios, and it uses cellular data, but it's not on a cellular network. So you don't get worried about all the frequencies and all the other stuff. Honestly, it's fantastic, because you can talk to somebody nationwide. Whereas the old radios that we had, we might have 5 or 6 miles maximum distance. I was driving in this morning, and I was just coming through Odessa, which is still 60 miles away from the launch site, and I could hear every conversation of the launch operations team.
Oh, really? Oh,
Yeah,
wow.
it was really
I heard
amazing.
that you could. They'll if you keep the phone, they'll find you fairly easily.
That's true. That's true. And so with the student version of the radios, we actually can see every radio walking out. So we know each one radio is handed to each team, and they go out. They have to check in every 30 minutes. And if they go into an area that they shouldn't, our dispatchers will contact them saying, Team 110, Team 200, Team whatever, you're going into a dangerous area, please stop and turn around, or hold tight where you're at. So we definitely have a high level of safety in the operation space, especially when you got rockets going off as often as we do. So, and again, this Motorola system's been fantastic, and looking forward to learning even more about it, using everything it's capable of in the years to come.
That's a wonder. I'm glad, and I thank Motorola for their support too. They're wonderful. In fact, there's a Motorola rep here, isn't there, helping?
I have yet to see that person. I would definitely like to talk to that person.
Yeah.
Uh-oh, somebody's calling me on the real radio. Hold on.
Oh, somebody calling. Oh well.
This is Andy.
Taking off.
Copy that.
Oh, Andy's got to do a little work. He is as executive director, he gets a lot of things. Mic's off. Okay.
Okay, can you guys cut me off for a second? Can you guys mute me for a second?
else went live. Okay, apparently what's happened because of we had a mishap on the stand. There was some burning material on the ground, so we had to send crews out to put out the fire, as it were. So we're probably on a hold now because of that.
Shortly, it won't be a problem at all. The great thing about the area that we have out here is it is, for the most part, a significant amount of dirt, rock,
Sand and dirt,
debris,
yeah.
dirt, and even the shrubbery that is out there, as you can see a little bit in the bottom corner there. That stuff is very hard to burn because it's used to being very, 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 very rigid plant life. So it's kind of hard to get a raging fire going, but we have EMS and fire available on site, and so they can easily call for additional assistance if necessary. And the Reeves County Fire and EMS Department is a huge supporter, and
those guys are
very
great
exciting.
too. My compliments. And that's all a volunteer force, isn't it?
I don't know for sure. I do know that they got some really nice trucks.
Yep.
And a brand new facility that I saw, I think, being built down in Valnare, which was pretty impressive. So very
Well,
nice.
this is. I mean, since this is the last year since I was here, it's facility's gotten a lot more. We use the word permanent.
Yep. Yeah. And so we'll see.
This building for one of them. So
This is not, this is a rental. We bring the
Rental,
building out, but yeah, we've got the Conex containers here, and the good thing is when you clear out a whole bunch of road and area, it doesn't grow back too quickly. So we did spend quite a bit of money clearing out areas. So we did change out a few of the launch area pads. So we sent the solids a little bit farther out to ensure we've got safe recovery distances. So made a few changes here and there, but for the most part, we're still in the same launch ops zone. We still have a large number of canopy tents for the students, and hopefully we won't have another scary windstorm like we had last year.
Yep.
That was not fun.
Now the Midland Development folks have been also very supportive of us in the past, haven't they?
Absolutely, they're the main reason we're here.
That's
Honestly,
right.
I'll make it real clear. The Midland Development and Visit Midland as well put their names in the hat for hosting us, and we spent several days over here visiting the site, talking to all the resources and the city council members and quite a few others, and we were excited to hear about all the opportunities, and the FAA was very excited about the possible options of getting a very high waiver. And so we worked out all those little details.
So what's the altitude waiver we're allowed to go to now?
So we actually do have a 100,000 foot waiver.
1,000-foot waiver.
100,000.
Foot. Wow.
So it's about a third the way to space.
Yep.
So we won't be flying to that altitude today. In fact, we've self-limited our opportunities here due to the various winds and some other activities that are there. We've got to make some additional changes before we can start letting teams do those altitudes. But we do have that waiver, and we're excited about it. And that was one of those.
This is a pretty rare thing.
It's true.
Waiver.
True. Not
For
not
amateurs to come here, that'd be the mecca.
Yeah, there's probably about a dozen sites maybe around the U.S., if that have 100,000 or above foot waivers, and we're excited to be one of those. And so that's why the teams come. Honestly, the opportunity to fly to 45,000 feet is not something that teams in countries like India and even Malaysia and all the international teams, very few sites can do that. Canada, I think, has one launch site, and that's for their Launch Canada event.
Timmins,
Timmins.
Up in northern Ontario.
So, very few places you can do that, and that's why we attract the number of teams that we do. We love to watch the teams progress, where their first year of the team, they may compete in the 10,000 foot category, and then as they do well and they expand their skill set, they'll bump up into the 30,000 foot categories, and then potentially even the two-stage 45K category. So those are all exciting opportunities, and we're starting to open up some new opportunities in the future. I know our beloved president, Steve Taylor, and I don't know if I'm officially allowed to tell people this or not, but I know that he is pushing very, very hard to release an opportunity that might involve, I don't know how to quietly say it, remote control aircraft that are launched using rocket engines. So RC controlled rockets, drones, aircraft type things. And so it's going to require a lot of infrastructure. We'll need runways and a few other things. So we'll see how this works out, and we'll come out with the details. But
This would be a great place to fly RC.
well, and it is. And
Wonderful.
the neat thing about it is it combines aviation, where you always have a lot of aviation folks, and then you also have the rocketry portion of it. So it's sort of a little bit of both worlds. And with our major partner AIAA, they already have an RC aircraft competition, one of the best ones in the world, Design, Build, Fly. So we're going to dip our toes into that with rocket-propelled RC aircraft. So it'll boost the RC up, and then it's just gliding, RC glider. So and then the category and how we're going to be judging those and evaluating those, not sure. Still working on those details, but it should open a lot of eyes. And we've been doing the same categories for a long time.
Yeah. Well,
so
we could, there are other competitions, for example, like the hovering competition for rocket. That would be a thing to do out here too.
Oof, yeah, that's true.
And we have, this is one of the places I can think of to do hovering rockets. And the hovering rockets don't go that high; they go maybe 300 or 400 feet up. Translate a few hundred feet. That's their thing. This would be a perfect place for that. So that's and it'd be a great thing for students to build.
And very challenging.
Very challenging.
Very
That's right.
challenging. So,
Very challenging.
to do that, you've got to be able to do a lot of control systems.
That's
a lot
right.
Of,
That's right.
A lot of
Control
nozzle
systems.
gimbaling, and
Throttle
so
control.
many different things.
Oh.
Yep, we're getting an update from LCO.
Remember the LCO's in launch control.
Yep, launch control is giving us an update now that they've cleared the debris and the issues that were out there. They're saying pad Bravo 2 is the next pad that's up on deck. Hopefully we can get a team number. That would be helpful.
Okay. Just amazing how many teams we got. We have teams from every continent except Africa this year.
Absolutely.
We've had teams from Africa.
We have.
So, except for Antarctica, there aren't any universities in Antarctica. So, yeah.
I know the teams from Algeria have always done
They've tried
well
to get
here,
here, but they haven't
and the
can't
visa.
do it yet.
The visa
issue,
challenges
sure.
are very, very specific for them. All right, so that's University of Louisville is that team that's on pad B2.
I have quite a relation. I'm the
That's
Liquids
right.
mentor
You're
at Louisville,
Liquids
so
mentor.
So, yeah.
I remember visiting with them
Yeah,
all those years ago.
That's right. That's right.
Yeah,
They
University
have
of Louisville.
a great system. They're able to. They have a good setup. They have a great facility at Louisville They have 3D printing some machines, metal.
Very
so
nice.
they can do that, and they have their own X-winder. They have a machine shop. A very University of Louisville has an excellent maker space there. So for
Yep.
the kids, and they do a great job. And there's I was looking at their solid stuff. It looks pretty good. And this is the first time they've been here. Think about how many teams have been here for like 3 or 4 times, 5 times. And I've had students that are telling me that there are seniors. They've been here for this is their 4th year here.
Nice.
So it's
Every year, and can you imagine what their resumes look like?
yeah. Oh yeah. I tell them
You
their
know,
resume. If you want to go to work for the big space companies, put this down. This is the kind of thing they want to see. People building rockets.
Absolutely.
that are
You can have a fabulous GPA, you can have a great major, you can go to a great school, but if you've never actually done anything besides study, the companies are looking for how quickly will you come up to speed. Well, if you've already done a lot of this rocketry stuff in this competition that applies back to your real world job, you can get hired pretty quickly because, if somebody with a better GPA maybe would take twice as long to come up to speed in the position.
Mm-hmm.
So they really are taking in the hands-on experience portion of your resume, and that's why we're here. The book knowledge is fantastic, but we provide that opportunity. ESRA's mission in life is to give these kids a very staggeringly difficult technical challenge to do stuff that they can't normally do anywhere else. And that's, again, it's the perfect formula, and that's why the attraction, and we get so many different huge number of schools. We had to turn away 20, we had a record number of applications last year. We accepted a record number of applications last year, but we still had to turn away 25 plus teams.
Wow.
So, and it's not an easy process, we have 6 safety evaluations, with the last 2 are being right here, hands-on the week of, and not all teams can make it. So we unfortunately we had about 30 teams that this year had to either drop, whether it was financial, technical, school issues, or team issues, whatever the case might be. But the ones that are here are the cream of the crop. They are doing it, and they are passing all those criteria. They've come up with the financial challenges and resolved those, and they've got to be very, very proud to get to the launch pad, because that is a culminating, fantastic, and there's still chances they may not launch, or they may have a CATO, or may have a challenging recovery. But still, they made it here, and that's a win.
They made it here. That's a big win.
That's a win.
I've talked to teams. I've been impressed with the amount of time they go out and do fundraising. They do a very good job. They not only does the university contribute money, they go to their alums, and now they're at the point where the alums they go to are previous competitors. So that helps a lot too. And I know I've already met one team who's the guy who is their mentor competed here like 8 years ago.
Nice.
So it's so this stuff is beginning to become something that's generational. So and I know a lot of schools. For example, I do liquids for 3 or 4 schools, and a lot of those kids have gone to the big aerospace, the big SpaceX, the Blues, Rocket Labs.
And as they move up the food chains
That's
in those
right.
organizations, they remember and they return to us.
That's right. That's right.
So,
so there's a lot.
not only the opportunity to wear one of these fabulous blue shirts as an ESRA volunteer, but even just recommending that the company sponsor or participate with us. And we've already had a couple of those come forward. It's been fabulous. I know Blue Origin has brought several of their new hires on that were competitors.
Yeah.
And they having a freshly graduated professional engineer working at Blue Origin or another fabulous aerospace type company, talking to competitors and telling them what you're doing now and how it applies. Oh Lord. Okay, we just heard from LCO. Yeah, it looks like we're going on a wind hold, and that's not a good sign.
Wind has come up. Yes, that's not unusual here in West Texas.
Yeah, the usually afternoon time frames 2 to 3 o'clock.
And we have a.
Yep. All right.
Our wind limit is 20 miles an hour, and its gusts are above that now.
And so, unfortunately, when we do go on a wind hold, there's no options. We have very strict rules that we follow those, not only from the Tripoli standpoint, but the over 20 miles an hour sustained is just
difficult to fly no matter what.
So, hopefully the winds will drop down. Maybe it's just a temporary thing. So, we'll keep watching that. But right now we are on a wind hold, which means the rockets that are on the pads now are going to stay there. Yeah, you can see the dust flowing.
The gust,
Yikes.
yeah, the dust is worse. Yeah, with the wind do it.
Ouch. And the hotter it gets here, the winds will go even faster and faster. Good news is we have an interview coming up here very soon with our premier partner, AIAA.
Oh, okay.
So that will be happening here in a few minutes, and we're excited to have them. AIAA has been a longtime supporter of the IREC. As long back, almost 2018 or even earlier before then, that I can remember. And so we've just recently, in the past year or two, have a much better, stronger MOU in place with them. And ESRA participated in a few of their conventions and conferences. So, we're helping them integrate the student chapters and the student members into their organization, and AIAA is helping us get in contact with sponsors that may not be, potential sponsors that may not be aware of us. And if they're looking for opportunities to gain access to some of these students. So, there's so many opportunities for these students, and to have more and more opportunities with the employers coming in here. So we've got brand new sponsors like Perseus Defense and quite a few others this year that are joining us. So we're excited to have them, and that's how AIAA is going to be helping ESRA. So it's a fantastic partnership. We're excited to have them in here, and we'll be talking to them in just a few minutes.
I'm an AIAA member.
Excellent.
Senior member, thank you.
Very nice.
So there's the wind. You're looking at the winds of West Texas, and it is a desert. Interestingly, this is the Permian Basin is the one of America's oil reserves. So it's if you look around here, you'll see a lot of oil refinery going on, right? Or drilling and pulling the oil out of the ground around here. Very big area here. I was every time I drive in here, you look around, all you see is the oil industry.
Yep. So again, just an update for everyone. We are on a wind hold. Unfortunately, the winds are. Yeah. So the winds are up over 20 miles an hour sustained. You can see everything blowing all over the place right now. So hopefully they will calm down in the near future. But until they do, we are at a wind hold. So again, we're going to be bringing AIAA in and having an interview with them in just a few minutes.
Okay. Are they coming in here?
I believe so.
Okay.
Or is that in the other room, guys?
Okay. We have another room too?
I don't know.
Well, one of the good things about this is I've seen a lot of students that have, like yesterday when we were at the Horseshoe Pavilion at Midland, a lot of students were communicating. They were going to look at each other's, and a lot of these teams have the same problems. So it's interesting how they go around and lose. How does somebody else solve the problem? I saw that quite a bit yesterday with the hybrids.
Mm-hmm.
So I was very pleased with it. And I'm certain that's going on today. It seems to walk around and talk to each other. They get a lot of interesting, particularly the foreign teams will get to talk to other teams. And it's a great thing. You're learning, meeting people from all over the world who are doing this exact same thing you are.
Yeah, it was, I remember there were several students who I'm familiar with and they knew me pretty well. They were walking around inspecting and checking out all the other designs, and they would come running up to me and go, "You've got to go check out this team. Oh, they're doing this, that, and the other." And you just, it was like a kid in a candy store kind of thing. And they're like, "We never thought about doing something like that." And, that is fabulous. That's how it works. So we're pretty exciting about it.
Okay. And it's coming up soon, and we're off. Are we still on live, guys? No, I guess not.
All right, guys, we are back. So we're going to kick off a wonderful interview here with the CEO of AIAA, Mr. Clay Mowry. So, Clay, thank you, sir.
Andy,
Good
thanks
to
for
see
having
you.
me.
Absolutely. The partnership with AIAA between ESRA has been relatively new. Mm-hmm. So we're in our first plus year, a little over a year. And as the executive director of ESRA, the key pieces I've seen that have been a huge benefit for us. Access to your largest conventions. So you guys have two major conventions that we're super excited about. SciTech, which this past year was in Orlando, and then another one, and that was the Ascend conference in Orlando.
In Washington.
In Washington, D.C., just recently. And ESRA got to participate in that. We had student teams there presenting as well, and both of them gave us access to all of those resources that AIAA has their hand, and we got to talk to new potential sponsors and explain what's going on. Students were able to talk to some of these companies as well. It was a huge win for us. And how about updating us on what does AIAA get out of working with ESRA?
Sure. Well, first, let me just start by saying we love this partnership with ESRA. We think this is a great partnership, super symbiotic.
Great,
and,
absolutely.
It's win-win all the way around.
Mm-hmm.
When somebody was, I took this job about 20 months ago, and I said, "Do we have a rocket competition?" And they said, "No, we do DBF for the aviation, but we don't have a." And I said, "Well, who's got the best rocket competition out there?" and everybody pointed to you guys.
Yeah.
And so I told my staff, I said, find out how we can go and partner with those guys. We don't need to put it on, but we could benefit. We have a network of 277 universities around the world that are part of AIAA. And when I come to this conference, this event, only about half of the teams here are part of our network. So we want to expand. We got a goal. We want to expand to the 70 plus teams that are here that are not part of the AIAA
And that
family.
includes the international.
A lot of international universities. By the way, of our 277, about 210 are here in the United States. About 60 are international.
Yep.
But there's a ton of room for growth to expand there. So you've got competitive teams from universities around the world that we want inside our network. We've got an even bigger network than that we want those universities to compete here at IREC. So I think that's a perfect thing. The other piece that's been really important for us is to be able to publish those student papers that generate both from our conferences and here. So it's a big piece for students when they get published in our library. So it's called the Aerospace Research Center, and that ARC catalog is the largest collection of aerospace technical publications in the world. It's over 200,000 publications that are inside of that, many of them peer-reviewed and very high level. Obviously, these are student papers, a little bit different class, but it's the entry point for people that are doing technical publications. And so we want to start that muscle memory early with students, get them to publish with us, and hopefully they'll continue on in their career path with us, where they'll join one of our technical committees. They'll keep publishing through the course of the career. Then they'll go back and mentor when they get to be our age.
And my personal experience going through university was, you publish when you're a PhD. You don't publish in undergrad, unless you are a very specific, lucky individual. And to be able to do this at this scale is just, I've never heard of anything like it.
It's
amazing.
fantastic. So we do student conferences, 7 student conferences around the country. We're broken into regions geographically, and so those student papers, and we have competitions on student papers there. Then students are now coming to our largest forums. You mentioned Ascend, and SciTech is 6,000 people. We had 2,000 students there. And they are publishing some really important works. A lot of them, they got the faculty advisor, and they work through these things. And they're doing, computational fluid dynamics. They're doing thrust vector control. They're doing really interesting topics and papers that come out of some of the practical experience they have here at IREC. So they're learning and they're publishing, and that's a great place to start.
And it goes straight into the resume again.
Exactly.
The stronger the resume, the more skill set, the quicker, bigger thoughts, bigger aspirations towards potentially going to graduate school. If they weren't thinking about it before, now they got opportunities. But I would love to have a couple of published items on my resume, but to have that opportunity coming out of undergrad, it would be huge.
Look, if there's any students, or if it's K through 12 or you're in school, a couple things I always say. One is you want to be a team competitor, right? That's the first thing that companies look for on your resume, is you're a team competitor. Second, you want to be a published author with us, right? Wow. And then join as many activities as you can to bolster that resume. So internships, even if it's volunteer stuff, and a variety of companies, that shows that you've got some real practical experience. And so the companies know coming in, you've already been a bit vetted, you've already been published, you already kind of know how the ecosystem works, and working in teams is what you do when you're in companies. Everybody, none of this is it's a team sport. Rockets in space are a team sport, and so you have to know how to work together as a team, so it's super important.
And watching the teams just out there, when the winds are coming up, hey, they were getting ready to go out the pads, now you got to change plans. You got to be extremely flexible, and you can't let the stress get to you. You can't get upset. You got to work on plan A, plan B, and plan C. And it's amazing to watch some of these teams deal with some of these challenges, where they may go to a final safety inspection and run into a problem that they've never heard of before. And now they're having to re-engineer or change some minor issues, whatever the case might be. But they're having to step back, saying we cannot proceed forward until we resolve this, this, and this. And they do a fantastic job on that. And so that's the opportunity we have to give them these launches. Now, again, not every team makes it all the way through the process, but the excitement is watching them push and keep pushing and keep trying and burn the midnight hour. They do the midnight. They work extremely hard to get this finished, and it shows in the end. These teams that are going on this first day, I know we're in a wind hold. It's nothing we can do about good old Mother Nature in West Texas. However, the amazing amount of work, you cannot undermine what or underscore what they've done to get here and to be able to launch in the first morning salvo. That's like the cream of the cream. And so they're doing a fantastic job there. A lot of teams that are waiting patiently. Luckily, we've got another 2.5 days. We're going through Saturday afternoon, or Saturday around noontime is our final option. So hopefully the weather will work with us and we'll be able to slide through this. But the heat generates the wind, and the wind stops the rockets.
Yeah, it's windy and dusty out there, but I think it's going to lay down a little bit later on.
Fingers crossed.
Yeah,
Fingers crossed.
No, it's amazing to see some of these teams here too, internationally, particularly the ones that come from the southern hemisphere, Australia, Argentina, some of the other places around the world. And they're, by the way, in finals now, back home, right? Because it's the reverse in terms of seasons. And they're here, and some of them I was talking to yesterday, chatting with, they say, oh, we got to take our exams a week later because it was so important to come and compete here at IREC. I thought that was just an amazing story.
The University of Sydney is a great example. The first time they showed up, they were the very first Australian university. And I knew when they showed up, this team was so well organized. And they set foot, out on the desert area here, and they would come walking up to me. They are dressed appropriately. They've got, their boondock hats on, their boots, and they're ready for the desert. And they go, I started apologizing for the heat and the dirt and all that and stuff. And he goes, what are you talking? This is just like home.
It's the Outback.
This is great.
It's the Outback, right?
And so this team launched almost immediately on that first day, and they could have easily gone back and gone to the hotel and just chilled out and did whatever they wanted to. This team was so well organized. They spent the last 3.5 days helping other teams recover rockets. There was a team that had to leave early and they lost their rocket, couldn't find it. And that Sydney team put a sub-team of recovery and found that, I think it was University of Pennsylvania, found their rocket, and we had to ship it to them.
That's amazing. We get similar stories at our design build fly competition where we have a lot of crashes, right? I mean, they're trying to fly unique mission sets. The plane goes down, and then they spend all night trying to rebuild, and they get help from all the other teams. And we have one team, I think it was 11 different teams, help them, with parts and pieces and design cues and things that they could do to implement to get flying back the next day. And that's the best part of these competitions. When you see the student competitors just pitch in and try to get the most out of it, because everybody's in the same feeling, about camaraderie and participation. So it's a competition, but it's a friendly competition.
And having been to DBF a few years ago and watching the skills of those RC flyers, I cannot do that. I've attempted even on the software side of it, and it's just like in the ground every time. And so, a huge respect to them. And the key difference I always notice, and maybe one of the reasons I like rocketry better, is you point it up and you push a button.
No human involved in that operation. Just the button.
As long as you've done everything right, it should do what it's supposed to do. But when you've got skills involved of those RC pilots, and it's just amazing skills, it's neat to watch.
We saw that this year. Really, it was illustrated because in Wichita we had a shifting wind pattern on the tarmac, and so you could tell who had the good pilots that knew how to navigate, particularly at takeoff. Because it was a crosswind coming, and a lot of the vehicles just kind of skidded off and then would go nose down. And the skilled pilots knew exactly how to point it and deal with it and get the plane in the air. Just for people watching the stream, these are roughly wingspans of basically 4 to 6 feet on these planes, and so they're a couple of meters, but fairly powerful, and have to fly 3 unique mission sets. So it's a really interesting competition to see how the teams adapt the design, much like the payloads here yesterday when I was talking to the teams about the different kind of creative payloads that they'd come up with. Really interesting stuff.
It always has been. Some teams don't get very excited in the payload space, but our partner SDL, they have been a fantastic supporter for us for years, and they've got prizes now, and so more and more teams are coming forward with even more and more advanced. I mean, we get microbiology, and some of the requests that we get are just, is it okay if we put a laser in our payload? And I was like, whoa, hold on, what are we talking about? And what about radiological material? Can we put it? So he's like, what are you talking about? But when you listen to them, they have these amazing ideas to put into basically a 2.2-pound payload area, not big, 5 inches typically in diameter, and maybe 12 inches tall. And some of the stuff that's come out of it, especially the winners, the winners every year, the first, second, and third, and the choices that they're made for all of these different areas. Very exciting stuff. And as SDL likes to point out, the rocket itself is just transportation. The value, the reason you're launching that rocket is payload. And so that's very valuable, very true.
Yesterday there was one with a rover that would deploy after it came down and landed and have a 360 camera on it.
Nice.
There was another one where you were talking about biological. They have pig's blood in this thing, and they were analyzing the impact, the acceleration on that one. Another one was a slosh. They had 3 small tanks that they were going to look at cavitation and slosh during flight, which, by the way, is a real for big rockets.
That's a real one, yeah.
It's a real one. So really kind of interesting, creative.
Baffle design, all that. Yeah. Very exciting. And again, that's the stuff that'll put right in your resume. And those are the things that all the big companies are dealing with. So, it is exciting. It is pretty neat.
It's amazing the creativity that these students come up with. I had such fun interviewing, I think, about a dozen teams yesterday on the floor, and the different approaches and the different design function there. And some of these teams are 15, 20 students, and they've all got a specific element that they're looking at. Part of the vehicle, the structures, the guidance, navigation, control, the propulsion systems, the overall architects, and the payload architects. And it was really neat to see them and kind of how the interplay worked between all, because all vehicles, all launch systems are complex systems of systems, right? You have different kinds of systems and geometries and basically acumen, right, that it takes to build and design to each of one of those elements. And that's why they call it rocket science, right? It's the complex systems of systems where you could have a failure mode in any one of those things, and that is the end of a mission. That's a binary kind of business to be in rockets. It either goes where it's supposed to go or it doesn't. You hope you don't have a catastrophic failure. But these things were at that level of engineering from a student perspective. They learn how the interplay of each of those systems has to work like an orchestra, right? Like
Our judges are trained to evaluate even those functions. While we do judge the paperwork, making sure that the reports are effective and well written and to the point of where they need to be without being overly wordy, the judges are also evaluating the teams. How's the team interacting? How's the team performing? Is there leadership? All of these different challenges, they spot where teams are doing great things and they spot where the teams are doing not so great things. And so all of these scores get brought into a final judge evaluation. We'll call it like when the new pope is being elected, all the cardinals come together and yes, this one candidate may have the highest scores, but, all the candidates are like, yeah, well, he's pretty good. But, when all the judges come together and like, the scores will get you in the top 4 or 5, but then it's really just about, hey, we think this team had a better organization, or this team seemed to deal with their challenges much better than the others. And so, it's not always the best score wins type scenarios. So those top 1, 2, and 3 teams overall, it's a very interesting evaluation process, and it's worked. I mean, we've been doing it almost 20 years now.
That's amazing.
And so, it's really important. If the team is highly focused on safety, hey, that's a big, big plus, and that gets notated. And when these judges come together, they're like, hey, they did great in every spot, but I noticed this one point where they didn't do very well. That's the kind of stuff that they talk about for hours and hours on that Saturday afternoon. And eventually they do the white smoke, and a team has been selected as the overall winner. And, it's very exciting at our closing awards ceremony where we have our keynotes and all that, but the kids are sitting there just chomping at the bit, waiting for that. Who's winning? Did we do well? Are we in the top 10? Did we win it? So I was talking about the University of Sydney, the only team that won it twice. They won it last year, and then they won it in, I think, 2019, if I remember correctly. And so I walked up to them in the convention yesterday and just made sure they understood that you can't win 3 times. And then they're looking at me like, what?
They've done well at DBF, too. I want to say 2 years ago, they won the Best Paper Award. They've done quite well in the competition as well. Also New South Wales. The teams from Australia come to play.
Yeah.
They come to play. RMIT, they really, and that's a long way to travel to come to the U.S. to compete in a competition from down under, but you can tell that they put a lot of work into it.
And they're gonna laugh at me if they're watching this. I had a comment to them after Sydney won, and I was like, what this is gonna do. They're like, what are you talking about? And the Australian accent they have, I just love. I was like, there's going to be a New Zealand team competing next year, and we're going to do New Zealand teams the very next year.
That's fantastic.
Oh, it's too funny. But love those guys, and again, all the new teams. I mean, we've got not only teams, but whole organizations, government entities in Malaysia, Indonesia, Philippines, quite a few other countries, not only in that sector, but around the world that are reaching out to ESRA and would like to know how do we get our universities excited and engaging and trying to compete in this, how do they, as a government entity, create launch sites, create the resources and the pool of money, the pool of whatever that they need to make their team successful. And we love that. I'll spend hours and hours and days talking to these folks to help them out. Where they start picking out, they wanted to have an island that have a launch site on it, and might not work out so good. Water's not real good with rockets, but
right.
Nonetheless, they're throwing options at us, and that's we're asking us for input and feedback. I love that. I think the whole concept, if we're doing our job, we're doing it well, it should be spreading. It should be spreading out everywhere. And we watch other competitions pop up, and some of these competitions will grab our rules and literally do cut and paste. And we love it. Great. If that gets your competition off the ground and gives these students more opportunities out there where maybe they don't have to travel to the other side of the planet. Fabulous. Fabulous.
Launch sites near water historically have been great for expendable vehicles, right? So you're doing the rocket equation, you want to shed mass as you're going up and you want to drop those stages in the ocean. It's benign. They become a coral reef someday. But when you talk about reusable rockets and vehicles that you want to recover payloads from, land is better. And land that's flat and dry, and you can actually go out and drive across. No trees.
Yeah. If you want to launch them again,
exactly.
It helps to land them on land. So,
yeah.
So, anyways, I want to thank you for your time.
Sure, thank you.
Is there anything else that you would like to chat with the folks about AIAA?
Well, look, just to say, our organization is 33,000 aerospace engineers, students, professionals around the world. We're growing. We've got a tremendous amount of passion around rockets and airplanes. It's the most exciting time right now in aerospace in my lifetime. I've been doing this for 32 years. We have electric takeoff and landing planes. We have reusable rockets. We have small satellites that are providing internet connectivity around it. This is the most exciting time for aerospace. Huge amount of demand for careers in aerospace, for good engineers. So it's a lot of fun to be involved in competitions like this now and to watch this next generation. We call them the Artemis generation. Artemis 2 just launched to space. So we're trying to really reinvigorate the students that are coming up through this because it's a different feeling than it was 10 or even 20 years ago about what's the possible, right, in this. By the way, huge amount of new invested capital. We could see that with the SpaceX IPO, but all the space industry out there, a lot of investment coming in. So a lot of startups now, and this is driven by compute power, artificial intelligence, CAD/CAM design, additive manufacturing. All of these things coming together allow us to shrink the design cycle and get to something that's producible and flyable much faster. And so to all of you out there, you're in the right place. I hope you have a passion for space and rockets, and come to IREC. And this is the place to be out here.
And all of those functions, we have these students using those same operations in a lot of these rockets, where some of these components are additive manufactured. Almost all teams are using simulation software, various different simulation programs, and we've got sponsors that are handling a lot of these for us and providing the software for free. So again, very exciting time across the board. Now, you mentioned Artemis. I've got to do a shout out. Shout out to a schoolmate of mine, a gentleman that I knew very well when I was, he was my cadre staff sergeant, platoon sergeant at school, and astronaut Randy Bresnik, the commander of Artemis 3. Every time I see him, I start shaking and, getting into my little freshman, he was a pretty strict and amazing guy. But pretty strict sergeant back in the early days.
So speaking of Randy, I know his wife, Rebecca, who's an attorney with NASA, and she's actually one of the best space lawyers on the planet. So both a really power couple when it comes to space.
And she was pregnant when Randy was on the station, I think. or maybe I'm just
On the
making
space
that up.
station.
Yeah.
Yeah, that may be. I don't know the timeline for that.
I know
Yeah.
that he was supposedly the only astronaut to become a daddy while he was up there.
Is that right?
Yep.
Okay, yeah. No, she's
think
based
I'm
out of
right. I
Johnson,
think-
but she's often at NASA headquarters.
Yep.
But she's one of the, with respect to the ISS agreement and how that works
Nice.
from a legal standpoint, because of all the nations that are up
That's
there at
cool.
the same time. She's the one that has
Yeah.
all the knowledge base around
Yeah.
how that agreement works and how the liabilities and all the conventions work
Yeah.
around it. So she's an amazing in her own right. But
Well,
married to a guy who went
Yep.
250,000 miles away
Oh,
from
yeah.
planet Earth, the farthest that humans have ever traveled. That's pretty amazing.
So yeah, Randy's always been an amazing guy. He's a Marine Corps,
Yeah.
F-18 pilot, and
Yeah.
for he's done all the amazing stuff that astronauts are supposed to do.
Yeah.
And so very proud of him. And go Citadel,
Yeah.
he's our only astronaut so far from our school. But
Yeah. Anyways, yeah, it was. That's good stuff.
yeah,
Is
exciting
that really
times.
your only astronaut?
Yeah, it's the only
Oh,
astronaut.
okay.
It's a small school.
Yeah, yeah. Well, Artemis was an extraordinary launch. We just announced the crew for Artemis 3.
Yep.
Now Artemis 4 will be going back. Hopefully we're going to be back on the lunar surface this time to stay by 28. We'll see if
Yep.
we can make that
Well, so
timeline.
there's-
A lot of things to happen between now and then, but it's an exciting time nevertheless.
Right.
And we know that there's other nations that are trying to get human beings on the surface of the moon, including China, and they've already landed on the
Dark side.
far side.
Yeah, far side.
All right, so you got to think Gary Larson and not Pink Floyd on that
Gotcha,
one.
okay.
Just a
Yeah,
dad
gotcha.
joke. Sorry about that. But far side of the moon. So they've already put a lander there. India, by the way, has
Yep.
also landed
Mhm.
there as well with their Chandrayaan 3 mission. So a lot of things happening on the moon right
Yep.
now. It's really another space race that's going on. With a lot of countries now participating with the technology to launch and land.
And as we all know, competition is great.
Yes.
We love competition. That's what drives so many different groups, and certainly drives ESRA.
Absolutely.
So,
Yeah. Well, thanks for
you,
being
sir.
here, Andy. I appreciate the
Absolutely,
opportunity.
Mike. And thank you very much. Take care.
Take care.
Hi, everyone. We are returning, and we have with us one of a dear friend of mine. I've known you now for 12 years, I think.
Yeah, that or longer.
But I was one of those creepy followers when you were out there launching those really huge rockets
Oh, man.
before your board of directors days. So Mr. Gerald Mew, who is board of directors with Tripoli Rocketry Association. Tripoli Rocketry Association and ESRA are probably linked tighter than any two organizations can be. And it's very, very vital to do that. Tripoli sets the national standard, and the unified safety code that they provide to us gives the safety factors and the experience. And what are we talking now? 60 years? I know.
Yeah, it's been a long time.
So again,
decades. decades.
Tripoli has been developing and improving and making leaps and bounds of trying to improve and create a safety code that doesn't completely restrict you to launching little tiny rockets, but allows you to do some of the larger rockets safely. And so ESRA's standpoint is we easily could have just gone out and did our own thing. But we don't have the experience. We don't have the expertise, and particularly the years and decades of experience that Tripoli did. So partnering with them and being able to access that safety code has been invaluable for us. And so I want to go ahead and let Gerald here talk a little bit about Tripoli, what Tripoli is, and why it's important, I think, for the entire world. They're international. I know you're growing significantly in the international space too, but talk a little bit about Tripoli, what it is, and why it's important to high power rocketry, particularly in the United States, but growing around the world.
Well, thank you, Andy. I appreciate it. And I'm cool just to sit here and let you continue to talk, because you pretty much said a lot of the great things.
Stealing all this thunder. I'm sorry.
No, this is good. I really appreciate it. And, hello, folks that are watching and listening online. And we can kind of see a little bit off to the side here. So I even saw Whitney Richard make a comment to say hi, Skippy. So hi, Whitney, and hi for those that are online. I know right now it'd be fun to be flying rockets, all the months and years some of these teams have done and prepared, but sometimes the weather gets in the way, and we're kind of then on a holding pattern until weather becomes more favorable to fly and operate the rockets in safe and best opportunity to be in a successful manner. So you get some extra time with us to have some commentary and talk a little bit about like why, like who we are, what we do, why are we here. So again, thanks everyone that's been sticking with us for the live stream, and we see you, and I'll be able to watch a little bit of the comments off to the side and see it even as I look back at it later. So appreciate that. And yeah, one of the representatives here of a Tripoli Rocketry Association, been around for several decades. What we do is as an organization, and working closely with the Ezra crew and hosting this competition through IREC, is being able to provide that platform of flying rockets, operating it in a safe manner, and providing that expertise that kind of transcends through everywhere, truly as an international organization. And we do try to do our best to make sure we are demonstrating as an international organization. At times it might feel difficult just because of operating in different environments, whether it's location, whether it's different types of regulations. So we navigate through that as best as we can with the information we have at that given time. But yeah, it's fun to watch our organization grow from a membership standpoint. I've served on our board for Tripoli Rocketry Association. I'm at 13 years, and when I first got on, we were a membership of about 4,500, 4,700, and as we've expanded and worked with our partnership with the Ezra Group, Andy, and all the folks that have been a part of it, providing the working with Tripoli is to have the insurance and coverage to be able to operate this in a safe manner. So it's that kind of key foundational spot. But membership has grown quite substantially, so we're now at that 9,900. We've eclipsed 10,000, so it kind of goes that back and forth.
Nice.
So it's just wild to see membership grow that much. And a little bit even more into that, our membership is about close to half being student members. So so it's pretty neat to see the growth of the organization, and like really what we've been able to do to work together to provide that partnership. So it's fun to see like where it's gone and grown. And so sometimes the question becomes, as a lot of members here are for this competition, and some being international, it's like, don't know what Tripoli is. Why do I have to have Tripoli? Like, what is it? How does it exactly work? And I'll say kind of its most simplistic form is the be able to provide the insurance coverage, but it goes even a little bit beyond that. It's being able to help pass over the institutional knowledge that many of us, even Andy and some of the folks that are what I'd say like my rocket friends, we've done this hobby for me, like even just as one individual, I've been doing this for over 20 years.
I remember.
And I did it as a kid. So I started off with model rockets and graduated into high power rockets. And I'm still considered one of the new kids on the block. And I'm like, I've been doing this for 20 years, and it says I'm new. So what that does is when we're seeing a lot of new members and student members that are wanting to do rockets and being able to try to be that bridge between I want to do rockets and I want to be in the industry, we're trying to help be that conduit along with, as we're really propelling that all the way across. So it's providing the expertise, providing the insurance, really showing and demonstrating safety and consistency, and like what works, what doesn't work. Like for me specifically, I don't have a strong technical engineering background, but you'd be surprised. I could look at all these rockets and tell you with a pretty good amount of confidence it's going to work or not work. And nice thing with Andy and crew is they've already vetted all that, so I can walk around and say, yeah, they're all going to work. But like at a normal, let's say, launch, and someone's trying to do something to really push the boundaries of, like, let's say, rocketry, what they know, I can look at it and just know this probably may have maybe not a nominal flight. Here will be the reason why. So that's really what we can do from an organizational standpoint, is to help provide that. We offer additionally the certifications. So being able to graduate up, it's hard to hop into a hobby where there's a lot of moving parts and go, okay, I want to fly 10,000 feet, I want to fly 30,000, I want to fly higher. We help do that through certifications and kind of graduate the program for members to want to fly a little bit bigger rockets. That's all regulated by impulse, and so again, it helps provide bigger motors, higher altitude, and we can help educate and teach folks so they learn it in a safe manner, it's repeatable, and then they can be able to have knowledge transfer from member to member. So those are like I'll say in its probably overly simplistic form of like what we're doing from an organization. And one thing I also forgot to include is we do a lot of work with our authorities having jurisdiction. So when you talk about all the different governments, the other different bureaucracies, they all have to exist. There's reasons for that to happen. What we can offer and provide in Tripoli is be able to create that space because of our long track record of safety, history, being able to bridge that gap of training and ingenuity and doing it safe and having fun. We help bridge that with those AHJs or authorities having jurisdiction, or the different governments really around the world, and even helping prime and prep some of the international, we'll say, sections or chapters. We call them prefectures all around the world, to equip them with the right information so they're having fun, they're doing it in a safe manner, and you need some of that to let folks fly rockets. So like, I really enjoy the admin part of it. I got in, as Andy remembers, I was all into the big rockets and wanted to push the envelope, but I knew in order for me to do that, someone had to be able to set that operation or platform up for me to do it. So I've kind of tried to take my expertise and interest in admin and spend time on working on the admin side of Tripoli. So I see like folks in the chat that have the ability, or folks here in this event, to be able to fly the rockets, because it's hard to do both very successfully and have a lot of fun. So I'm taking on that burden along with the other directors, with the other leaders within Tripoli, whether it's our prefects, our TAP members, our committee members. Thank you to all what you've been able to do to help support it. Other organizing groups because of this. I mean, a lot of our friends here with Ezra are Tripoli and NAR members, and all kind of birth this through that as the vehicle. So like, we're all friends. It also, like, it can limit us to be able to fly rockets. We always talk about stuff we want to do and fly, but doesn't sometimes always happen.
Well, and you said it perfectly in the fact that if all of our range safety inspection teams, and we don't want to confuse those with the judges. So we sort of had the judging group are the folks that evaluate and score the overall quality of it, but they're not really focused on safety. Now, our range safety team, those are the folks that they don't care about, this was painted perfect, or that this engineering document was written perfectly. They're focused specifically on Unified Safety Code from Tripoli Rocketry Association, and how does this rocket meet all of those criteria? And any criteria that does not meet has to be resolved. So they either give, you're good to fly, you're not good to fly. There's no in between. And so to get to that level, to be able to evaluate a very large rocket, so we're talking 5-6 inches in diameter typically, and upwards of 8 to 15 feet in height, these are not little rockets. Going 10,000, 30,000, 45,000 feet. And a lot of these students are coming out saying, they don't have, say, the experience of a Gerald Mew or myself, where we have 10. So we can't just let them build it based on what they think's a good idea. We pair with mentors, advisors, and most importantly, a flyer of record who does have that experience. And so while the students are still building it, they're getting the expertise, they're getting the feedback, they're getting the direction from these experts, and the definition of those experts is made by their experience as well as their certification level. And the Tripoli certification level, the level 3 requirement is I'm proud to say, literally every single range safety inspector that's on our team is a multi-year, usually decades or more, level 3 flyer that has flown rockets like that and bigger, for a very, very long time. They have crashed rockets, they've learned, they've got all those scars, and we're trying to avoid potentially having the students running those same problems. But the neat thing is the standard that's created is, just like you said, if one Tripoli range safety inspector looks at a rocket and follows the Unified Safety Code, the next person that comes through there, whether it be yourself or anybody else, should be catching the same potential problems. It's that framework. The framework is super important, and it allows us to move forward. Another thing I love about Tripoli is you guys manage Tripoli motor testing. So all of the commercial vendors that are out there in the world that want to, hey, I want to make a commercial motor. Well, the government has basically entrusted Tripoli motor testing from Tripoli Rocketry Association to certify that motor. And so there's a whole testing process. So it's like the testing, for food and other systems. You guys do that with rocket motors. You want to talk about that real quick?
Yeah, I can talk a little bit about that.
Love
It's
that.
funny the parallel with food. So that's my day-to-day work jobs. I'm in the food business, so yeah, being able to work with those different types of levels of government, and we're being able to self-regulate in those areas to test and verify motors for transport utilization, and that will provide a foundation of consistency around motors, so it works within tolerance, and it almost becomes a constant of a whole rocket project. When you think about and take a step back of a rocket, think of all the different things that can go wrong, and the only thing goes right is it goes up and a parachute comes out. So all these different potential failure points, one of those being the motor, and then you start to focus in on the motor itself. It could be even more, it could be even more, it could be even more. So with the motor testing, we're kind of validating through that the performance, the safety, the characteristics, the assembly, the utilization, and that even comes with as manufacturers look for ways to optimize performance, optimize materials, manage around their cost. That comes back into Tripoli motor testing to verify and validate. Yep, this still operates within a range, a tolerance, with updated instructions so that the member knows to be able to say, okay, I can do this, I can rely on this area as being a constant, and then also helps put the other parts of regulations or regulatory areas minds at ease and don't have to worry about it. We take care of it. That's the one thing we do take very seriously within the organization, whether it's us as the board, our TAP members, our prefects, our other leaders, our committee members. We take everything we do very seriously because we want the safety, we want the longevity of the hobby, and we want to be able to have the knowledge transfer and folks to have fun in the process. So sometimes it may not feel like it's fun, what's with all the rules, but there's a reason for it, and it's for mainly the safety aspect. If you take a step back and look at any type of regulatory area, so there's something that involves potentially fire, something that flies that can be unguided, there's things that are sharp, there's things that are metal, there's different types of material. Yeah, let's just not do that. Let's just completely not do that. So when we can say, hey, we can do that, we can operate in a safe manner, we can be able to provide some rules and then also add with some guidelines so that we can do this stuff, because when you think about where we've been able to go within this planet and look to go beyond the planet, some of this stuff comes from us. And I'm proud to say I'm a part of that, and all of us are very serious, whether it's Ezra, whether it's other organizations. We want to play a role in that to say, hey, we've been able to continue that space exploration, deep space exploration, going into other planets. We're playing a part in that. So it means a lot to all of us, and we need to be able to have a safe foundation to operate, and also the foundation to inspire those future engineers. It's beyond me where I can go today myself, but if I can do my part for our organization or for rocketry in general all around the world to say, yep, we have now kind of advanced where we are to play that part as that next part of exploration, then I know I've done something right.
And Steve Taylor, our president of ESRA, has a fantastic quote, and he says it almost every year that's out here. With these 2,000 students that are out here, we're fairly certain that one of those kids or more is going to go to Mars. I mean, there's a very, very high likelihood, and whether that's just by itself is holy cow, and that's very, very exciting. We love seeing the former competitors come back to us as volunteers, but even better when they just get out in the industry and they do amazing stuff in the industry. They're the lead composite engineer on the lunar lander. That's phenomenal. Holy cow, building something, putting your hands on something that's going to be landing on the moon, and doing that successfully is just amazing. And so, I love the students, love the energy, love the excitement, and the opportunities they have are so much more exciting, I think, than when fortunately I was growing up. It wasn't quite so many. We had shuttle, we had ISS, that kind of stuff, but now it's going gangbusters.
Yep, it's a whole new renaissance of
Love
rocketry.
it. Love it.
So it's fun to be here and be a part of it and see all the excitement from students, whether it's this competition, other competitions, local launches, preparation, and other types of rocketry events, or just seeing folks online or on the internet and watching where this is going and growing is pretty impressive and remarkable. Trying to mix words here.
So I'm gonna step back to sort of my personal experience and why Tripoli is so important to me. Let's see, 2009-ish. I've got a 7-year-old, 8-year-old that's wanting to get into rocketry. We did every SD's model kit that was out there, and we're like, hey, son's looking at me going, what's next? It's like, oh, you need to go to Tripoli Houston. We're like, what the heck is Tripoli Houston? So we go out to a launch site and meet a couple of wonderful people that are still dear friends. Mm-hmm. And they started showing us mod rockets, mid power, excuse me. And we had no idea you could go above A, B, and C. That's crazy. And then they started launching H's and I's. And my son's eyes just got huge.
Oh, man.
And so, it's like, oh. And so I knew I'd finally found that one thing that my son really wanted to do. So you got to feed and feed and feed. And we were traveling the country. We were going to Airfest when he was 13. And, we were doing all sorts of these amazing things. And he just could not get enough. And so he was the 8th Tripoli mentor. Number 8. Okay. He was number 8. He was super excited about all that. Got to fly a high power as a junior member, which was super exciting. And so all I can say is finish this off by saying, he full ride scholarship to Arizona State.
That's my alma mater. There we go.
That's right.
Yeah,
that's right.
I went there.
And he did graduate aerospace engineering, and he's got a fantastic job up in Northern California. And he's making good money. Holy cow, making really good money. Very proud of him. And the stories like this are all over the place out there. But if you're watching this and you've got a young person that is, very interested, excited, or maybe he hasn't tried it yet, I am highly, highly recommending give it a shot. I mean, you let him try soccer, you let him try basketball, you let him take him to a rocket launch. It could be, he might be one of those 1 out of 10 kids that gets those crazy eyes. And you just got to keep feeding it. And it's a fantastic hobby, and it leads to so many incredible things. And when you have an organization like Tripoli that gives those opportunities to younger people and allows them to stretch their wings and leads to a fantastic, they study harder in school because they want to try different things. I remember my son did a chemistry paper on the impact of pressure on burn rates. And he used a rocket motor as a test platform. And so he was so proud of it. He got an A in the paper. He was talking to all the colleges and during the interviews. And those interviews were always entertaining with the universities and the scholarship programs, because it started out with 40 seconds of tell me about yourself, and then went 2 hours talking about rockets.
Okay. Wow.
And it was fantastic. He always came out, I was like, yeah, we talked about rockets.
Well, and Andy just actually sparked us a couple things that came to mind. Is one thing about like this organization, Tripoli Rocketry. I mean, when you take rocketry in totality, provides a platform for a lot of different areas of like growth as a person, as an individual. Like hearing your story about your son is awesome. Similar path for myself is I did model rockets as a young kid, and I wanted to do more and grow, but I was a little maybe more quiet, a little more slightly introverted. And I kind of like felt like I was at home with folks here. Like everyone treated me like family. The very first time I came out to a launch, we like to give advice within our hobby, probably a little too much advice at times. So there's no shortage of people and team members and folks wanting to help, wanting to get new members in, wanting to have that moment and spark of like success and learning and thinking. And it's fun. Like that's just what our hobby offers. And I'm talking the hobby in totality, whether it's Tripoli as the organization, NAR as the organization, Ezra. I heard Clay speak earlier from AIAA. We all are very passionate, and the members, the folks at admin are all just super like passionate and excited and want to help others. The other thing you mentioned when hearing about your son in the story with like rocketry and like being the 8th member of the Tripoli mentoring program, and I'm proud of this about our organization with Tripoli. We never stay static with what we do. It may come off that way sometimes with, hearing members, observing launches, but know that like that's one of the parts I'm always looking at is like my role as one of the 9 board of directors for Tripoli is how do we stay relevant? How do we stay fresh? How do we stay safe? how do we know like we're in the right spots with the different governments or authorities having jurisdiction so we can still continue to operate in a safe manner? I remember like when we are doing this new venture within Tripoli, having liquids is one of the things we can do now.
What a great segue. Oh, man.
That was over a half-decade-long
Wow.
process.
Yeah.
It's not just like, hey, let's do
Oh,
this
yeah.
and let's jot it down on a
Oh.
napkin. No, this was a multiple-year like endeavor to make sure it's safe. We're tapping into the right experts, testing processes out. I was very involved with that process.
So can I give context?
Yeah.
So first jumping into ESRA, getting engaged in interviewing, hundreds of different universities around and having them literally virtually in my face about liquids. Oh, we got to do this, that, and the other. Oh, we got this liquids program and we want to do, bi-liquid propulsion. I'm like, no, we can't do that. That's not in the Unified Safety Code. Yes, we understand you want to do that. And liquids by itself can be one of 1,000 different orientations. I mean, it can, you got cryogenic, you've got all sorts of dangerous, deadly chemicals that you could put in. And so, I while talking with Bob Brown and other Tripoli members, years past saying, the kids are going to do it. We gotta put this in a box and get it organized and really, I don't know how to get this going. And over the last, 4 or 5 years, Tripoli has instead of just saying, no, we can't do it. No, not yet. We got to learn more. And they really were putting in the time and the effort. They just couldn't outright tell us, hey, we're going to have it turned on. We're going to go with liquids in 2026. But Bob Brown really sort of drove a lot of that, I think. And maybe there were others. I don't know behind the scenes.
Yeah.
All I know is when Bob made the announcement, I was like, just giggling and
and it was a lot of work, a lot of process, a lot of research, and like what you mentioned, Andy, there's so many different iterations. When you say liquid rocketry, there's so much to it. And same could be said even for solid rocket motors, the different types of compositions of it. So that's why we kind of landed in one area, because that's what we could best understand, best teach, best try to understand safety and guidelines around it, and still gives autonomy to our local like prefects and leaders to say, yes, we can do it, or no, we're not ready for it. So we know there's some evolution that will happen over time, and continue to evaluate like what are those next iterations. For me, one of the things I like as the role for one of the things I take a lot of interest in for protection and safety of the organization is risk management. So I do a lot of evaluation of what does this do for the organization if there's an incident, or if there's crossing with a authority having jurisdiction or a government, like, well, what is this? What are the limits? So I have to I take an extra time and effort to evaluate what are those risks and pitfalls, and be able to have those types of conversations with other leaders within the organization or adjacent organizations, so that we can do it, proceed with caution, or we need to hold or pause, or this is outside of the scope. And that's another thing I need to probably mention is like scope of what we are. There's different types of iterations within rocketry. So we are kind of that, I'll say, truly, it's high power rocketry, but it's hobby rocketry at its core.
So amateur,
If we want to do true like amateur type stuff, that's out of the scope of really what we are. If you want to be like a commercial venture and organization, you're on your own there. Like, good for you, excited to see it. I'll watch the video
That's
of
right.
it, but that's just not really the limit of where we are. We're really trying to focus in on the hobby stuff, and we can be that entry point of like getting the basis and a foundation of rocketry, not the and the one and only, but is a form of it. And then if one wants to progress further beyond that, way bigger motors, way higher altitude, way like more unique complexities, one can do that. They'd have to kind of navigate through the not through our organization, but through governments to be able to do bigger, higher, more unique. So just know that there's a limit to like where we are and what we can do. Now that limit, I would say, is a pretty large limit.
Welcome to the United States.
Well, and even like when someone, I want to be level 3, I want to be level 3, like you can do some really impressive stuff with a K motor or a level 2 motor or a level 1 motor.
Oh, yeah.
I mean,
break speed of sound, break twice the speed of sound. I mean, a lot of exciting
pull
stuff.
high
Altitudes.
pull high G-loaded type
Oh, yeah,
projects,
yeah.
high altitude, test new things, test new recoveries.
Yep.
So I always give that advice to someone like, hey, you can try other type of rocketry at that certification level. We don't have to go right to level 3
Sure.
to think
Right.
I can do rocketry. You can do rocketry, pretty unique stuff out of even at a level 0. Like,
And Tripoli has a tremendous number. They hold the records. You know, they have all the altitude records for the various different impulse levels.
I know a person.
Somebody
I know a person in
have
that
a couple
committee.
of those.
Yeah,
And you hold a few records, I believe, correct?
Former.
Oh, somebody got you.
Yeah, so I've been overtaken on a couple of my
you gotta
records.
fix that.
Yeah, and I want to, but it's fun to be able to see that. I'm one of the members on the contest and records committee, so I get to see those attempts come in, or the new records that are beaten, and see like what they've done and how they've done it, and be able to say like, you know, be a part of like publishing and broadcasting. But then like at one of the Tripoli launches, we host an event once a year called Large Dangerous Rocket Ships. I didn't pick that. It was something from a long time ago. We just say LDRS, but our committee hosted a Skippy Cup, just a little like
That's
contest, just a small fun contest. And the idea was, we're called the Contest and Records Committee. All we ever did was records. We never held a contest. So like, let's just hold a contest. And it was a very fun, approachable contest. It's a level 1 motor, an H motor, and you're flying. It's essentially like a certain diameter, certain length body tube to the highest altitude. So it's an approachable contest that Manny did, and it was in its second year this year, and people had fun, and they're asking, hey, how can we do the Skippy Cup contest again? So it's fun to see that even with something that seems so simple and basic, the amount of ingenuity, the engineering, the technical work that some done, and then even just some of the fun, like creative and marketing side of it, is impressive to see. And I forgot to mention that about what our hobby offers is other types of like fields you can go into. Like you can learn to be great at marketing, you can be great at looking at program and process management. For me, I learned to be in the food business and just like admin and like managing systems and processes and working with people and leaders and being able to work up, down, and across organizations. So our hobby can offer so much more than thinking, oh, I'm going to go be aerospace, mechanical, electrical engineering. It can help you be a communications expert, program management expert, systems, like or like IT, like all this stuff. Like this is a nice like crash course for folks that want to learn and then meet some of the coolest and most unique people within this hobby. Whether it's be someone of a leader of an organization to someone that's just got the last couple bucks to their name and this is the hobby that they truly enjoy to do. Like this hobby just offers acceptance to all of it, which is really cool to see that.
One last little topic,
Yes.
and this is personal to you.
Okay.
So with AIAA just a few minutes ago, I was talking to their CEO,
Yeah.
Clay Mowry,
Mhm.
and they talking about design, build, fly, and
Oh, yeah.
RC,
I know about that project.
RC aircraft
I do
and
that.
all that kind of stuff.
Yeah,
And,
I do a little bit
well,
of that.
yeah, Gerald here might be, I don't know, a champion of several forms
Yeah.
and factors in the RC space. So when my skill set is really good at building a rocket that pushes the button and goes straight up, and that's all I can do, he actually can do both. He can make really big rockets go, and he has the skill set to do
Yep.
the hand-eye coordination and win, championships.
Yes,
I remember seeing all that.
Yeah, one of the hobbies I do outside of rockets and like my heart and passion is all rockets with my friends and admin and being able to fly and watch stuff. I talk about rockets as though I don't care about rockets. I love the rocket part of it, but I really enjoy like model aviation, and I actually started doing RC airplanes first as 4 or 5 years old with my dad, and then that's how actually I found rockets was when I go into the hobby store to go to the model airplane section. You actually have to walk by the rockets. I'm like, what's that? And so that's actually how I got into rockets was through model airplanes, and until
Nice.
this day I still fly model airplanes. I actually race them competitively and enjoy it, and that's a whole nother, like you've got to be able to have all the type of aerodynamics and
Oh my God!
combustible
Well, just
engine.
the hand-eye coordination and the reaction speeds and all of those. I mean, you're
Yes.
talking like hundredths of seconds sometimes.
Yes,
That's
this-
just-
and so when you want to fly
Ugh.
low to the ground, you better
That
make
is-
sure you know what you're
That
doing.
is
So,
mind-boggling how skilled he is. So
but yeah, it's a fun hobby, and really like that's neat. Like what the AIAA or AIAA does with the design, build, fly. So I'm aware of that program, and it's almost like what Ezra is doing in kind of their own form and format, and like we're all kind of working together to this to be able to help bring that next wave to industry. Like we're trying to make sure we were aligning and working with the industry partners to help get us to that next level of where we need to be. So it's fun to see all of this kind of come together.
awesome. Well, thank you, Gerald.
Thanks, Andy.
Appreciate your time. Any last comments from Tripoli you want to tell the world?
Yeah, I guess for the world, yeah, because this is truly
That's right.
this is the world.
Absolutely.
First, I want to say thank you all for sticking with us, being on live stream, being a member of the organization, or if you're interested, you should look to join the membership. Be patient, be hungry, be inquisitive, and just take it a step at a time. And appreciate all of you. To never feel like you can't have a conversation with myself, or any of the other leaders, anyone with Ezra. Like, we're all just people at the end of the day. And like, I remember when first getting in the hobby, I was this real excited fanboy, like, oh my gosh, these folks are so like elite, and I can't talk to them. I'm just a regular person. Like, I walk, I walk with one foot in front of the other, or sometimes they bump into each other. So like, I just say that, and thank you all for joining in and being a part of the hobby. The hobby doesn't exist without our membership and our partners. So thank you for that, and see you out at the next launch and range.
Awesome.
Thank
All
you.
right. Thank you, everyone.
Thanks, Andy.
Absolutely.
sponsors and everybody who is currently watching our live stream. I know we've kind of went silent for a while for this wind hold, but we wanted to just chime in. Sorry, they're doing some announcements. While we are currently on a wind hold, our launch operations is actually trying to complete additional safety reviews and to get as many people out to the pads as they can. The reason they're doing this is so that when it comes time and our wind hold is lifted, we can get as many rockets off the ground as we can. So that's the update as far as the weather. I promise you, as soon as we go live, we will let everybody know. We aren't just doing this holding you hostage because. Additionally, we have a couple of items, including a credit card and a cell phone, that are currently at our Lost and Found. If you are missing any of these items, please go see Jamie in the registration tent. It's my understanding that she is also taking care of Lost and Found today. And last but not least, as always, we'd like for you to hydrate, whether that's liquid IV, Gatorade, Pedialyte, your beverage of choice, not only water. Just drinking water doesn't help you. It can actually hurt you in the long run because it makes you lose all your electrolytes and salts. So anyways, I'm going to go ahead and go quiet for a little bit longer. As I promised, we will be up as soon as we can. And we hope to start streaming again soon.
with one of our sponsors for IREC, OnShape. And to get started, could you please tell us your name and what your company does?
Yeah, of course. Thanks, Solo. Hi, my name is Shay. I am a member of the education team here at OnShape. OnShape is a completely cloud-native CAD software. So we're a fully featured CAD software, and you can access it online via the browser on www.cad.onshape.com. And so the really cool part about OnShape is that since it's completely built in the cloud, it's very accessible for teams. And so it doesn't really matter what sort of device you have. You can access OnShape on a MacBook, a PC, tablets, phones. We have an app, which is super great, and it makes it really accessible for teams to be able to work not only in their college, computer labs, but also at home on their own devices. So super accessible for teams. It's also collaborative as well. So a really cool part about OnShape is that multiple people can work on their models at the same time. So we know that there's a lot of teams here that have sub-assemblies for, like the fin can and the nose cone. And so all of those sub-assembly teams can be working together in the document at the same time, very similar to Google Docs, which is really neat because we know that, at certain times in the semester, everybody is free and able to work on the document. And so it makes it really easy to be able to share projects and then also be able to work on them at the same time.
Helps with a lot of coordination and I guess teamwork.
Yeah, definitely. I feel like the team leaders, a lot of IREC teams here use OnShape, and so we've gotten feedback that it's been really helpful as team leads to be able to get more students participating in these projects and have a lot of them contribute to the end rocket, which I know a lot of teams here have already launched, and some of them have used OnShape, which is pretty great.
Yeah, I noticed that a lot of teams have OnShape as a sponsor. So what benefits do they get with OnShape?
Yeah, that's a great question. So OnShape provides a software sponsorship for collegiate teams participating in competitions similar to IREC. We also do Formula SAE, rovers, rocketry, underwater vehicles, all that sort of stuff. And we give you something called the Education Enterprise. And so the Education Enterprise is actually a paid or like an education version of the same plan that we give our paying customers. And so companies like Garmin and Sonos, they all use that similar plan that we give teams because they work a lot similarly to companies than they do, say, like educational institutions, right? And so it's a completely locked cloud space. So as students come in, join the team, they're added to that space, and then they're able to work on the projects within there. And then once they graduate, they can leave that space, but all of the projects will remain with the team. And that's the really important part here. We know that there's a certain level of parts reuse that happens year over year, and so it makes it really powerful for teams as people graduate not to take any work with them, and so there's nothing really missing. We also offer CAM Studio, so the ability to manufacture the parts after you've made them within the same project, so they can design their rocket in OnShape and then also create those tool paths to manufacture them in the same platform, as well as simulation and PCB Studio, which is an ECAD to MCAD translator. So super great stuff. I feel like there's a lot of use, especially in rocketry, because there's a lot of PCB boards there. A lot of teams manufacture a lot of their parts in-house, and so it's a really great fit, especially for teams participating in IREC.
Interesting. So it goes without saying, how does a team, I guess, not only qualify, but how does a team reach out for the sponsorship, and how do they qualify? Yeah,
that's a great question. If you participate in IREC or you are intending to participate in IREC at any point, you can go to www.onshape.com/education/collegiate-teams. There will be a form that any team member can fill out, and if you are trying to participate in any of these competitions, as I said before, you will be approved and you will get on a call with me or one of my colleagues to set up an enterprise for the team and guide them through with resources in the future.
Interesting. So how do you spell collegiate real quick?
COLLEGIATE. Spelling bee.
Yeah. Well, let's see here. What else? Oh, also, who qualifies? Is it worldwide or is it only in America?
Yeah, it is completely worldwide. We have teams that are from Brazil and from India, as well as in the States and in Europe. So completely global. It doesn't really matter where you're from. And yeah, we would love to sponsor your team. It's very, as I said, it's very accessible. But then also a really good part of it is that we provide extra features with the enterprise, not just the extra CAD and CAM features, but also workflow features. So as I said, since it's similar to Google Docs, you'll be able to comment on documents even spatially within the model. So if I want you to change the fin can or a specific fin on the model, I can tag you in a comment and you'll be able to see it on the model, which is really neat. Another cool part is release management. It's very similar to like an approval workflow that many companies use actually in practice. And so for a lot of the teams that are looking to either get offers or jobs in rocketry like companies or any other like mechanical engineering jobs, they use release management workflows in order to maintain their products and their work. And so it's a really good way to get exposure to those sorts of workflows and even simulate it and use it within the team so that you guys will be prepared for the future in the workforce.
Interesting. So in there, you could also design an entire rocket in OnShape and then have OnShape print out the base of it, right?
Yeah, so what we do is we provide a lot of the like major export types, so you can always either 3D print them, or as I said with CAM, if you have the sponsorship, you'll be able to, you know, design those tool paths, simulate them in OnShape as well, and then send that G code to the CNC mill, which is really neat.
Interesting. How would a student, I guess, try to work for OnShape if anyone got interested in it?
Yeah, that's a great question. So OnShape is a software company, and so we tend to have really like two paths for how our internship positions, like two groups of where our internship positions fall into. The first one would be software engineering. So I know there's a lot of teams out here that have a whole software team that, you know, provides and creates that telemetry infrastructure. If you are interested, our internships go on around August to September time, and they go up on our LinkedIn, so I would keep a lookout for that. And then the other half is really interdisciplinary. So if you are a mechanical engineer that doesn't necessarily want to do full-on product design, you might want to explore a role at OnShape, because we have a lot of technical marketing roles. We have a lot of technical demo or like technical sales roles where there's a lot of engineers that have graduated with mechanical engineering degrees that their whole job is giving demos to customers and showcasing how awesome OnShape can be. And so if any of those sorts of roles interest you, I would definitely look out for a position at OnShape.
Okay. Well, just to be sure, the OnShape, what side do we go to again if we ever wanted to get like a referral for the sponsorship?
Yeah, that's a great question. So you can go to our main website, like the education website, at www.onshape.com/education. However, there's a page within there called Collegiate Teams, and that's where the sponsorship application form is. And so it would be www.onshape.com/education/collegiate COLLEGIATE-teams. Once you get there, it'll just be a form. You'll see all of there's a lot of teams, actually IREC teams that have their logos featured on there. So you might see some familiar faces, but yeah, it's a great sponsorship, and we know a lot of teams here like us, so cool.
Is there any other ways OnShape could be helpful to students, either like in college or maybe not doing IREC competition in general?
Yeah, that's a great question. So we also have student and educator plans. So if you want to test out OnShape without fully diving into a sponsorship, for a sponsorship you would have to pledge to make the majority of your rocket in OnShape. But if you want to test us out before really committing the whole team to a whole CAD switch, you can go and sign up for a student account. It's kind of in the same education website, and through there you'll be able to access all of the modeling features, not necessarily simulation and CAM. However, it's a really good way to be able to start modeling in OnShape, understand the differences and how OnShape works, as well as share a document with somebody else, look at the cloud features, because those are really the basis of OnShape's benefits. Like the ability for me to not have to put a file in a shared drive for you to take out and then work on it, and I can't work on it. There's just so much time that gets sucked in there, and especially as a college student, I know when I was a college student, I had such little time, and if I am to do 3 hours of work for my rocket, I want that to show up somewhere and be recorded. And so a really cool part actually about OnShape documents is that it saves every single change, every single click you have made in the document since the inception of the document. And so if there's any time somebody accidentally breaks the assembly or accidentally deletes a part, you can always restore it to a point in time when that didn't occur. And so we have some some really extensive versioning history and very like cool Git style branching and merging that teams can do in order to maintain the relevance of their document and test out different things through iterative methods.
Okay, so another question is, how easy is it to migrate from other softwares like AutoCAD into OnShape?
Yeah.
Because like many people have like either like assets already stored or already pre-made. So how easy is it to like import our old work into OnShape?
Yeah, that's a good question. So OnShape supports a traditional pack and go, and so if you take any CAD files from other companies or other softwares and put it into OnShape, it will show up as a dumb solid, so there won't be that feature tree, but it will still be parametric, and so you will be able to still use it for your models. A lot of teams have done that in the past, and a really cool thing about that is also you just have to do it once, and then as you keep iterating on it, it'll just exist in OnShape forever, which is really nice.
Nice.
Yeah.
Well, that sounds like a wonderful thing OnShape is. We do hope that you continue to sponsor IREC and all our students that come here. Is there anything else that you'd like to mention? Maybe something that maybe a bit more personal that you like about OnShape, or maybe something that might not appeal to everybody, but maybe like a niche little group that would greatly benefit from anything OnShape could offer?
Yeah, that's a really good question. I think the thing that I really liked about it is the ability for everybody, regardless of the time and experience they have in their team or in CAD, to be able to participate in a project. Like, we have had teams, or I've been on teams, where I can either contribute very little or a lot based on how much like I know in OnShape. So because of the branching and merging, because of the ability to retain all of that history, you are able to essentially participate as much as you want, and all of the information will be stored in case anybody wants to go in, edit, and so it really makes it collaborative. It allows for people to learn a lot more. Another really cool part about OnShape is that the founders already had made a CAD platform beforehand, and so this is their second time thinking about how to make a CAD software, which is really, really neat.
So they have like most of the kinks already worked out and everything.
Yeah.
Smoothed out.
Yeah, and a really cool part about OnShape is that they've really rethought what it takes to design, and what design principles can we really enforce through building a CAD software a specific way. And so what I really appreciate about OnShape is the ability to enforce those top-down design principles. We have the ability to do something called multi-part modeling in OnShape. So in a lot of other CAD softwares, you're able to do like, one file contains one part and another file contains another part, and the assembly kind of puts all those parts together. So if you have a change that involves multiple parts, you'd have to go into each of those parts and change them, which can be a really big hassle. But with OnShape, you can use something called a part studio, which allows for you to make multiple parts derived from the same sketch. And so a really cool part about that is, like, I like the example of like an axle and a wheel. The diameter of the hole in the wheel should match the diameter of the axle, right? And so if you want to change it in another CAD software, you'd probably have to go into each part and change it accordingly. But with OnShape, you can just take the sketch that both those parts derive from and just change that diameter there, and both of those parts change automatically. So you could do some really cool cascading techniques where you can have one sketch that's like the master sketch that all of or most of the parts derive from, and then by changing just that sketch, everything, like a couple of parts, can kind of change automatically and like lock into place still. So it makes changing really easy as well, which is really good because teams like this have to iterate quickly. They have to kind of move in different directions and kind of see where the wind takes them. And so it is really good for teams that want to explore and be a bit more creative in their design process.
Interesting. Well, how many, off the top of your head, could you tell us maybe how many teams get accepted for the sponsorship at OnShape?
Yeah, so if you are at a university or a college and you participate in any competitive like league, even if you're thinking about, oh, we just like created this team, we intend to participate in IREC, say 2-3 years from now, we will accept you and we'll make sure that you're set up with the infrastructure in order to bring a complete rocket, car, robot to competition. We want to make sure that you guys have the right tools in order to succeed. And so we're a little bit, I wouldn't say relaxed, but we definitely want the teams that want to do like big projects like these to be using OnShape. So I wouldn't say it's definitely like extremely, how do I say this? like it's
Competitive,
yeah,
maybe?
it's not very competitive. We just want to have a good bunch of students that like to do big engineering projects.
Interesting. Well, thank you again for your time.
Yes, of course.
We hope OnShape, like I said, continues to sponsor IREC and all their students. One more time, like maybe with paper and pen, could you tell us the website and where people can go to get the sponsorship for
Yes.
OnShape?
Do you want me to write that down somewhere, or do you want me to just spell it out?
Just you can spell it out.
Okay, cool. www.onshape.com/education/collegiate COLLEGIATE -teams.
Well, thank you again for your time.
Yes, of
All right.
course. Thank you.
And we hope to get back to the Rockets soon with all the weather that's happened lately.
Yeah, fingers crossed. All right, good luck, guys.
Good luck.
Cool.
National Rocket Engineering Competition. We are getting a go for launch, so we wanted to just give you a current list of the first 4. So our first team up is going to be Team 42, the University of Louisville. The second team up is going to be Team 304, Kent State. The third is going to be Team 301, Purdue. And the fourth team currently in line is Team 405, the University of Minnesota Duluth, who's trying again this afternoon.
So last time their ignition wasn't working, correct? I believe.
I believe.
That's what we heard.
Oh, yeah.
And so all the teams that you see are excited to go. They have been spending the day in the hot sun and wind. So we had quite the dust storm, which you might have been able to see on the live feed. So everyone's cars are nice and dusty out there. All the students are nice and dusty. Hopefully, if you have students out there, we've been reminding them to drink water. You can remind them to drink water. And everyone's excited. So the plan for later today is they're going to try to launch as many rockets as possible today, and the students will be collecting their rockets in the morning.
That's a little bit different, but of course, we are actually expecting inclement weather again tomorrow. So in order to give the students the best launch possibility, we are going to attempt to launch until sundown. So please try and stay tuned. As I mentioned earlier in the chat, our goal is to launch as many rockets as safely possible, and of course, weather kind of makes that a little dangerous. So we try not to go in that direction. Before we kind of get started with our launches, I did want to give a huge shout out to our drone crew. So this year, DS Pro Drones has also brought in some partners as well, and we are having them support us with recovery efforts. And they actually, while we were down, found a tail friend from Team 125 from last year. So shout out to the drone crew and DS Pro Drones. Kudos. All those missing rockets, we're going to find them this year. So Charlotta, if you could tell me what brings you here?
So I started working at Rowan University last year, and when I started, I had a lot of experience teaching capstone design in my previous job, and so they asked if I'd like to help out with the Rowan rocketry team, and I said sure. And a lot of volunteers have been telling me how they remember Rowan from Rowan. So he was a student, he was our team captain last year, very enthusiastic, and it was just his joy for rocketry was very inspiring. I think that this team is also very inspired by our current captain, and it's just wonderful to have students work through a project that's really engineering, very engineering intensive, but also very very fun. Sorry, we have voices in our ears right now, and as you might tell, I am not a media expert. I'm a professor. So the students get to do really cool engineering. They get to do, there's one team that has strain gauges in their tail fin. They have to do FEA, so finite element analysis, to simulate whether or not the rocket is strong enough to survive. Computational fluid analysis to determine what is the drag on their rocket, so they can predict to exactly what apogee it's going to get to, what height the rocket is going to get to. And so as a faculty member, I love having students do the science, do the work, and rocketry is such a strong motivation for students.
One of the goals for our Rocketeers, and what IREC is honestly for, is for the students to acquire that hands-on experience, so that the companies, of course, that they start to apply for after college know that they are capable of putting a rocket 10,000, 35,000, 45,000 feet in the air. Now, can you tell us a little bit about the COTS category? What does that mean?
So COTS means custom off the shelf, and this refers to the motor of the rocket. So there's the two acronyms that you'll hear the most are COTS and SRAD. So COTS is custom off the shelf, SRAD is student research and developed. So right now we have 42 University of Louisville. They will have a COTS motor. So that will be a custom off the shelf motor that they will buy from a supplier. They can build the grains themselves, so assemble the solid parts within a tube, put it in the rocket, prepare it, but the motor comes with the grains pre-assembled in the motor format for the most part. There's some assembly involved. and commercial off the shelf. I might have said custom off the shelf. I apologize. It's been quite a long day, and I've been in the sun for a while. Appreciate the help there. So for that, the students will purchase their motor, but then a lot of the parts on their rocket are going to be a combination of things that they've purchased and things that they've designed. So oftentimes you might see that the fins are something that the students have really put a lot of time and effort into. The bodies, some students will go through, wrap the carbon fiber themselves or machine fiberglass. Some students will purchase items, and there's a wide range of how much of the rocket has been independently designed versus assembled together. But regardless, it is quite a huge systems achievement to get everything working.
Okay. In reference to the COTS motors and our commercial off-the-shelf rockets, we'd also like to give a shout out to Wildman Hobbies and our Wildman Rocketry, as well as Aerotech. Without them, they are our vendors for the IREC, and without them, a lot of our international teams specifically would not be able to compete in this competition due to, of course, shipping issues, because we can't ship motors internationally. That's kind of dangerous.
Yeah, and it's helpful. Students can have their motors sent to the competition, whether or not they're international or local as well. And it just gives a nice way to safely store the motor grains, because that's not the sort of thing that you would want to have not necessarily want to have in a place where lots of people are interacting, but they have to stay in proper temperature, not too much hydration. So you want to have it in a good storage system, which is not always achievable.
I know one of the Indian teams, we were actually asked to store their grains in the live stream. I don't know if I should have said that online, but because of course they have to stay cold, and here it is super hot. I think somebody told me it got up to 110 earlier.
I think that was I saw that on the weather prediction when I just checked my app right before we went live. It was 105 degrees Fahrenheit.
105. Believe it or not, it still feels cooler here than it does on the East Coast where I'm from.
Just because of the humidity?
Just because of the humidity. It's crazy.
I'm also from the East Coast, and I think it feels pretty hot. So if you've been outside all day, it's pretty hot. But yes, it is not as humid, and it doesn't feel, it doesn't feel too terrible.
So we're just looking at the chat for a second. So the window, our FAA waiver actually opens up at 7 o'clock. So technically sun up to sundown, and that's all days of launch. So that's Wednesday, Thursday, Friday, except for Saturday. So our waiver, our FAA waiver, which of course is actually to 10,000 feet, even though our teams are currently only competing to 45,000 feet, though we do have a couple of demos. I'm sorry, they just told me in my ear that we have just went red flag. So we're going to be keeping an eye on that. However,
what does red flag mean? So some of the behind the scenes knowledge I'm not quite aware of.
Believe it or not, I am not a rocket person either. I am actually a parent. I got here for that. So
is your child participating this year?
He is not. He actually graduated, and because of the IREC, he was able to land a good position. So shout out to Joshua if you're listening.
Also, shout out to Katrin and Kira as well, because I'm also a mom, but my kids are 5 and 7, so it'll be a while before they start participating at IREC.
Train them early.
Yep.
All right, so we're going to kind of go dormant for a minute. Let's see if we can get this rocket off the ground. Traffic completely down. To the operations area, into the parking lot. So it's very important for all students who are out there to, of course, get out from underneath your tents and look up when the rockets come launch.
And so If you are just tuning in, this should be Team 42, University of Louisville. They are attempting to go to 10,000 feet with their commercial off-the-shelf motor.
Team 42, the University of Louisville, is the team that is getting ready to launch. Any other questions, YouTube, that we can go ahead and try and answer for you before?
While we're waiting, and we will interrupt those questions, even though they're text. I don't know how we can interrupt text, but you know. We will interrupt as soon as we hear this countdown or to give you any updates. Okay, yes.
As an elementary school teacher, I hear 6-7 all the time. And the fact that we just passed 6-7.
So, do you have info for how to share the team's rocket names or project names?
So we had actually developed a database for the live stream for that, but our database person, Michael, shout out to Michael, he's done a ton of work for us. He is also was a student rocketeer, and his rocket team is actually going to attempt to fly to 100,000 feet on Saturday. So for that reason, he is currently driving to his launch site and can't be here with us to help support. So we are actually having to work at night to fix database issues. So hopefully we will get that taken care of overnight.
And so one of the questions is, who are the next couple of teams in line? That is a good question. We are getting them as you are. One thing is that if you had students that you care about who told you that they were in the first salvo and they didn't go, they are likely to be in this salvo. If they told you they were in the second salvo this morning, so for those students who drove up here early for the sunrise salvo, they will be in either this one or the next. So I know Rowan University will be in salvo 3 after this set of rockets are going on. And a salvo is how many rockets? Do you know?
So on our solids pads, we currently have 18 possible rails. I believe they are currently attempting 16 at a time, just in case there's any issues, but do not, I'm not entirely sure. That's just what I've overheard in other conversations. And we have, I believe, 4 on the 2-stage pads. And since most of our hybrids actually bring their own rails, I am not sure how many hybrids we have out there right now.
Yep. And so for the hybrids, the gentleman earlier was discussing how they're concerned with the fuels that they have to work with have to be extremely cold.
Yeah, so the nitrous specifically, they have to keep it chilled. We actually bring in a ton of ice just to help support those teams to keep the nitrous cold. And because the weather has been technically so volatile today, they don't necessarily want to prep their rocket under those conditions with the heat because it's so high. So they're kind of sitting back and waiting before they begin that process.
Yeah. And so tomorrow, someone also asked about when we would start tomorrow. So while 7 o'clock a.m. is when it opens, there might be some more wind tomorrow morning. The weather prediction currently says that. If that's the case, we will start off with recovery, allowing teams to go into the field to recover their rockets, and then start a few hours after that.
So I will be honest with you, if we do go into recovery, we may take an hour or so past that just to recover our rockets, because of course we have to wait until daylight. Hold on, we're getting another rocket.
Okay, Virginia Tech is going to be the 5th in the queue. So if you are a Virginia Tech fan, then they will be going after University of Minnesota.
All right, so just to recap, first up should be the University of Louisville, team number 42. Second should be team 304, Kent State. Third should be team 301, Purdue. Team 4 should be team 405, the University of Minnesota, Duluth. And now we have team 50, Virginia Tech.
The teams that were upright on the pad for Salvo 2, I don't know about all of them, but a lot of them should be able to launch in this group. So what they did is they had the students go out, arm their rockets so that they'd be ready to launch. Arming the rockets means that they're turning on all of their flight computers so that they can get that telemetry data, so that they can have their live camera going on. And then due to the high winds, they had them turn that off to save those batteries, but they left the rockets out there so that they could launch. So I think a lot of those, if you heard from your students, they should be going, but some of them might have been recalled. I am not sure. We wish you could be here too. I don't know who that is.
Are there, as a rocket parent, while we're waiting, how many of you guys watching our YouTube right now are actually rocket parents? We would love to see rockets too. We're working.
So do we have 10 launches so far?
We have had 7 successful launches so far. Or I'm sorry, 7 launches because the University of Minnesota, I believe, had a technical issue.
Oh yes, and so we'll see them again soon. So.
Oh, I love your me's. Keep sending them. How many parents do we have out there?
Aww.
Hey, be sure to reference your university and your rocket team. We want to know where you're from and who you're watching.
Got someone excited for Kent State. They're coming on board.
Clarkson.
I have a cousin-in-law who's going to Clarkson or went to Clarkson. He was on the rocket team last year. I'm not sure about this year. So. MSU, is that Missouri or is that Michigan State? So the Michigan State, I saw their setup earlier today.
Team 30 mentor, nice. Carleton University. So yesterday, during the
Mississippi State.
Mississippi State. Yesterday, while we were at the Horseshoe, we did interview about 26 teams, and we hope to have those interviews up tomorrow.
Wonderful.
Specifically during, not during our rocket launches, of course, but while we're preparing for the next Salvo. So definitely stay tuned tomorrow, so we can, of course, so you guys can catch that footage. As we interview the teams, we kind of ask them a little bit about who they are, what about their rocket excites them, what makes them special as a team, and we had some really interesting.
Did you get to interview students about their payloads?
We didn't actually explicitly talk about payloads in general. I think we were actually going for more of an overall rocket idea. However, we are inviting the teams to come back after. So once they launch, of course, they have to go recover. And then once they recover, they have to take their rocket to post-flight and provide post-flight with all the information. Did the rocket come back all in one piece? Provide them with any of the telemetry, because of course we need to know how high they actually launched to. That is one of our awards. And but after that, they are welcome to come visit us in the live stream trailer, because we would love to hear about how their overall launch went.
Yeah.
So shout out to teams if you're interested in being interviewed on live stream after you recover your rocket. Definitely please come by and see us.
And I've heard from quite a few teams who have asked about that, so I will continue to send them your way.
Please do.
Because that would be wonderful. And lots of proud parents in the chat right now.
I love that. Just a reminder for those, because we do have several people here that are actually watching the YouTube stream. And just a reminder to please hydrate. Please hydrate. Drink your water, the Gatorade, the Pedialyte, the liquid IV, all of that important stuff. And not just water. I mean, we know we push water because it is hydration, but you need all the other stuff too. So the liquid IV, the Gatorade, and the Pedialyte are also just as important. parents, aunts, uncles, and siblings. Nice. Clarkson University has a very good following in here right now.
We aren't in Pecos, Texas. We are a little bit south of Pecos. Do you remember the name of the town we're in?
We actually have our own little address for the IREC launch facility. It's called One Rocket Way in Saragossa, Texas.
Nice.
Yeah. One of our great volunteers, Matt, who is not with us, no longer with us this year, he made sure that we made it on the map last year.
Fantastic. Okay, so we're getting a couple other team names right now, so hopefully we can let you know who else is on deck.
Okay, so I'm not sure which order they are flying in, but these teams are currently out on the pad. So we have Team 73.
And 73 is the University of Houston.
University of Houston. We have team number 5.
Team 5 is the University of Newcastle, Australia.
We also have All right, we're going to be quiet because they're getting ready to launch.
All right, we are ready to start. Our first one is Team 42, University of Louisville, Sovereignty. This is a 10K pot, predicted to 10,094, from 2,500 feet. We have green on Bravo 2. We have a clean sky on Bravo 2 on this. We have a clean sky, green Bravo 2. And we are going in 5, 4, 3, 2, 1. Lift off. Alright, we are on this road, we are safe. Charlie 3, 204. South 3, and there is 10K S-Rag going 10,500 and 4,010. We have a clear sky and a green light. We are launching in 5, 4, 3, 2, 1. Lift off. Ooh. Next up, Charlie 4301. Now, Charlie 4, 301, Purdue University, TST IREC. Chimera flying 10K S-Ray, 10,300, and 2209, and Charlie 4. Green light. Clear sky. Launching in 5, 4, 3, 2, 1. We have liftoff. Oh, nice job. Now, nice and clear. Straight up. Up and over. All right, ready to bank. All right, next up, Charlie 2. This is the University of Minnesota Duluth. Bulldog rocket team 405 on Charlie 2. There is a 30K S-Ray. Oh, 3220. 35 feet. Charlie 2. We are going in 5, 4, 3, 2, 1. Good night. You got to wait a little bit to make sure that one's in good shape. Next up is Delta 4, which is the Junior Tech 250. We are going to wait for a moment and prepare to finish out. We can make sure we have some finish place. We have no confirmation, so we are moving on to the Junior Tech 250. Carlo Fazilla, that's it. 10K hot, and 2400 thunder, 10,000 feet. The hold for the moment. Okay, we hold lifted. Charlie 4, Virginia Tech, 250. Clear sky. Hold on. We're stuck in the unsafe area. Hold on. sorry, I'm sorry, Delta 4, excuse me, Delta 4, Virginia Tech, 2050. Tech shot, clear sky, rolling 5, 4, 3, 2, 1. Liftoff.
And someone commented that there's lots of ladders on the ground. That's because, oh, that's a great looking one. They're gonna have a live feed, I believe. Oh, that's gorgeous.
Nice.
Gorgeous live feed. So these live feeds, the students are sending their information from the camera on the rocket to their personal computers, which are plugged into our system. And it's just incredible work.
All right, as we continue to watch Virginia Tech, we're up for, I believe, Team 73. I'm sorry, Team 5, Team 5.
Bravo 5. Oh, Team 5 is University of Newcastle, Australia. Okay, so it's Team 5 on Bravo 5. So each of the pads have a name, and so we have A, B, and C, or just
A, B, C, and D.
And D. Alpha 1214, which is Penn State, will be coming up.
Give us a moment. I'm writing all these down so we can get all this information to you guys.
And we're not sure why, but there seems to be a little bit of a delay with Houston. So,
actually, I believe it is a live video delay. They're trying to get them on a monitor.
oh, wonderful. Okay, so that's a good reason for a delay, just because. For a happy reason. There's green light and clear skies for Team 5, University of Newcastle, Australia. 2, 1. They've got liftoff.
All right, following up after Team 5 is going to be Team 214.
And that is Penn State University.
After Penn State is Team 218.
218 is Carleton University.
And then it would be 208.
And that's Worcester Polytech Institute.
And then Team 78.
78 is Michigan State University.
All right, after 78 is Team 202.
Okay, so due to the clouds, they are actually going to hold off on the 30K teams, which includes Penn State's team. So we're going straight to 78, which is Michigan State.
We can't launch into cloud cover because we have to be able to see the rocket. So again, safety is our highest priority.
All right, here we go. Next up on Alpha 4. Alpha 4 is Team 78.
University of Michigan.
University.
Michigan State.
Michigan State, I'm so sorry.
Sorry, I can't read the team. But it's a 10K shot on an M2500 Thunder.
So a 10K shot for Michigan State.
And here we go to the countdown. Here we go.
Here we go.
Clear sky, I think that cloud's good. We're going in
5, 4, 3, 2, 1. They have liftoff. We can hear the students cheering, and we're hopefully tomorrow we're gonna have some, or later today maybe even some footage of the students.
If we can get it all working, yes.
Be wonderful.
Sorry, live stream is definitely having some technical difficulties today. All right, next team is team 73. Oh, I'm sorry, please excuse me.
So they are figuring out who's going next.
Again, that's also out of the teams that we've already mentioned. So we are expecting team 87.
87 is University of New Mexico.
Team 41.
Team 41, Universidad de Antioquia, and they are from, did they say where they're from?
We actually do not have that on the list.
Okay.
If you guys are on the chat and you can tell us where you're from, we'd love to hear.
Universidad de Antioquia. My apologies. Clouds are still clear. They have the green light, and here we go. 5, 4, 3, 2, 1.
We have liftoff.
Looks nice. It's going into the clouds, but not too high. So, can have a little bit of clouds at that 10K.
All right, we are going to have to hold for a moment. That cloud is too low. We're reporting to the either wait till that cloud is clear or hold off and we will go on.
Oh, wonderful. Okay, so
Great.
I'm back here. So this is Charlotta DeVries with Rick Willis.
Rick Willis, and we're at the halfway through this Salvo, I believe, aren't we?
Yes, so we are waiting on the next launch. So there's a little bit of clouds that is stopping us from launching those 200 level teams, such as Penn State, Carleton, and WPI. So Worcester Polytechnic.
Worcester Polytechnic Institute, yep.
Institute. And so probably coming up, we might have University of New Mexico, Houston, or Embry-Riddle going at that 10K.
Okay. Yeah, these are the 30K screens, right?
Yes, so all the 200s are 30Ks. I think 300s might be SRAD 10K.
Mm-hmm.
So Texas Tech might also be coming.
Be ready to have your release after this salvo is complete.
Okay, the salvo is going to be complete here pretty soon. We're some comments are here. So a bunch of glad
Sure.
to see a bunch of parents that are up watching their kids fly.
And okay, we're going to see 73, which is Houston. University of Houston is coming up.
And they are a 10K COTS, 10K commercial engine.
10K. Alpha 5, University of Houston, Team 73 flying Juno.
Juno is the name of their rocket.
And 2500.
Okay.
Team number 73,
University of Houston.
10K COTS.
Clear skies, green light, Alpha 5 is going in
5, 4, 3, 2, 1.
Ignition.
They have ignition.
Don't have any confirmation yet. And we're watching for a confirmation. Embry-Riddle.
So Embry-Riddle is on deck. And someone asked in the chat if we have a schedule of teams, and no, we are learning because there's a lot of variable that happens with it. But now Embry-Riddle is going to launch.
Embry-Riddle. Embry-Riddle Prescott, the people in Prescott, Arizona.
Nice.
Compared to the Embry-Riddle who's in Florida.
Okay. So that's exciting. They're flying at the 10K level, 10K COTS.
We have a clear sky. We are launching in
5, 4, 3, 2, 1.
Liftoff.
Embry-Riddle's in the air.
So people are asking about their teams. If it's not a team that we have mentioned, we don't know when they'll be going. Hopefully, we're going to try to get a lot of rockets launched today. But we have the whole week, so there will be teams launching through Saturday.
Mm-hmm. Tomorrow looks a little challenging, but we'll see how that goes out.
Yep.
The winds today died down.
307. We have Texas Tech is on deck for the next launch.
All right, next up is Delta 1. Delta 1 is 307, Texas Tech University. This is West Texas Sunset is the team name. This is a 10K SRAD.
So this is a 10K SRAD. The students developed their own motor for this one.
They built and they also have to have their motor tested by sometime in the middle of May to come to here.
Just to make sure that it's
Just
working.
to make sure it works, yes.
Clear sky. We're going in
5, 4, 3, 2, 1.
There we go.
Okay.
Just had to press hard on
The announcer just said, there we go. They just had to press harder on the button.
Okay.
So always helps with electronics is to just press a little harder.
By the way, SRAD means Student Research and Development. Temperatures are a little challenging here in the western Texas. They're around 105, 106.
105 right now,
and
yeah.
They've dropped off just a hair. There it goes.
Oh yeah, so we see the video a little bit after you guys, but looks like a gorgeous launch up there. Sure, we have a group of very proud students, and as Jessica mentioned earlier, they are going to be showing interviews of students tomorrow, and then some interviews of students after their successful recoveries.
Once the end of the salvo is done, then the range will be clear, and students will, because they should all know exactly where their rocket came down, and they'll go to some people here. They'll get a kit to leave with a special tracker, so we'll keep track of them every step of the way, and they'll go and get their rocket.
Yep.
And so sometimes out there, somewhere in a few miles, and there are various roads they can traverse down to see, a dirt road, stop, walk out, get the rocket, throw it in the car, come back.
And the students have had safety training to make sure that they are aware of any hazards, that they have proper hiking boots, and enough water, which is
enough water,
the common phrase of today.
Mm-hmm. Hydration. Make sure your kidney drink enough water to make sure your kidneys work. So. So did Houston get it?
Oh, they haven't gone yet.
Oh,
so
okay.
Just marking off which teams have gone on our list. So
Salvo looks been pretty successful.
We got a hold. So we can start our 30K.
okay, they're going to have a hold to start the 30Ks.
Alpha 1, 214.
So we've got Penn
30,000
State
feet.
University. So they are flying a pink and white rocket, which is an honor to the Penn State's previous colors. It wasn't always blue and white; it used to be pink and black. So they are flying 30K cuts.
Penn State in upstate Pennsylvania, central Pennsylvania.
Central Pennsylvania. 3, 2, 1. We are liftoff.
Lift off. All right. That's good to hear.
So how long on average do the 30K flights last?
They're going to last. You're going to burn for probably 7, 8, 9 seconds. So you're moving at 700, 800 feet a second. So you're going to 30K. So that's going to be about 40 seconds in flight for apogee, and after that the drogue will deploy and will come down, probably doing 30, 40 feet a second. Then the main comes out. So it'll be probably 5, 8, 10 minutes.
Oh well, decent flight.
That's the range of the total flight.
So next up we have Carleton. They are on deck. Carleton University. 218.
Carleton 218.
Next up. 218. Carleton University, Alpha 2.
So it's Alpha 2.
In space. 30K contract, 5500.
They are flying the O5500 motor.
Big motor. Very
Big motor.
It's probably
We have a hold.
Small hold, which means we're going to wait a little bit. Okay, 5, 4, 3, 2, 1.
Lift off.
lift off.
Sounds like it went well.
We heard the sonic boom as it passed. So I think I thought it was a sonic boom. I don't know if it went supersonic or not. It sounded like it did.
Yeah, a lot of these 30K teams are going supersonic, which is exciting. 208 WPI Worcester.
Worcester Polytechnic.
Worcester
I think
Polytechnic
they're in
Institute.
Massachusetts, aren't they?
They are in Massachusetts, near in Worcester. Yeah, of course. So that's central Massachusetts.
Mm-hmm. That's one of the older schools, I believe, in Massachusetts, Worcester. It's been around probably a long time. They've been around as long as Ohio State's been around. I'm pretty certain of that.
I did not know
Ohio
that.
State's an 1880-something school, so I think Worcester's been around quite a long time.
Yeah, I went to UMass for my undergrad, so excited for their
That's in
launch as well.
Boston,
No, that's in Amherst, Massachusetts.
Amherst.
Yep. And so, waiting to hear what's going on with them. So we just talked about how launches can take about 8 to 10 minutes.
Mm-hmm.
And we also mentioned for, I think it was Carlton had the O5500.
That's a
Do you
very
remember
large motor. O
large
is a
motor?
Very large motor, yes. That's what you need to go to 30,000 feet. The O motor is probably
So speaking to
the O motor is probably 4 times bigger, 3 to 4 times bigger than the N. M's at the 10K COTS go.
Project Saturn. And so they're aiming for 30,000 feet.
Okay.
They're launching in 5, 4, 3, 2, 1.
You heard that?
Oh, we just heard WPI was founded in 1865, so thank you,
Okay.
Chet.
I thought it was. Yeah.
And they have liftoff. Wonderful job, guys. Yeah, so someone in the commentary is mentioning, or in the chat is mentioning that a lot of these flights were delayed. So these students woke up at around 2 or 3 a.m.
2 to 3 in the morning to get
Yeah.
here by 5:30.
And then to get, I think by 5 actually.
5,
Because 5:30 was the meeting, but they want to be in here. It takes a while to check in. And they waited this whole day waiting for the wind to die down so that they could launch. And so it's very exciting at how many
we
successful
launched a few,
launches
and then
we've
the winds
seen.
came up, and suddenly you couldn't launch. We were on a wind hold, and
Yep.
then that was what, 4 hours? We were on a wind hold, 3 hours. Something
It was
like
a
that.
while. I think it was 10 o'clock. And now it is, I think, 4 o'clock when we came back, so 6 hours.
Yeah, 6 hours. That's,
6
yeah.
hour hold.
It was enough time for me to drive up to Pecos and drive back with the hardware. So that's how long it was.
Okay.
We got some WPI supporters. That's good.
And I see some cheers in the chat for UTEP, and they should be coming up as well soon. 202, so University of Texas El Paso, UTEP. And I got to meet their mentor, very friendly guy.
Mm-hmm.
He's helping get people in the queue right now.
El Paso's on the very western tip of Texas, right before
Yep,
you go to
right on the border.
Right, you go to Las Cruces where we used to fly. You would go to El Paso and drive up.
It sounds like there might be an airplane. Is that what it says on the chat?
Could be. There's an airport just north of here in Pecos, so we could see, and it could be a general aviation aircraft just flying over.
Yep.
So that's certainly possible.
So it's confirmed they are holding for an aircraft because we do not want to make friends up in the sky.
Don't want to hit an airplane. That'd be bad. Usually they have something called a notice to airmen, NOTAMs, and that would say, don't fly near this area. So if the guy is cross country from somewhere to another, he might not read the NOTAM for a local area. So
It happens because in order for this event to go on, we have to get FAA approval.
yes, FAA approves the local landowners approve the use of land, and the FAA approves the use of the air.
Nice.
There's two different regimes of responsibility.
So we have University of Texas El Paso for 30K. They have a green light.
Green light.
Launching in 5, 4, 3, 2, 1.
Launch.
They have liftoff.
liftoff.
Congratulations
Good
to the
job.
University of Texas, El Paso.
In fact, there's not a couple hours from El Paso, there is a Blue Origin and SpaceX have test facilities there.
Oh, nice. So,
Yeah, so a lot of them go through El Paso to flights home. So in fact, some people I know who went to Ohio State, I was the liquids mentor for them. They got jobs there at, I forget what the name of the test site is, but they work so many days a week, and a lot of times they fly home. So it's El Paso's quite in the space business these days. Texas is in the space business big time too.
yeah, very, very happy in the state business. So 87 University of New Mexico is up. And so they are next to launch.
They're a
And
10K COTS.
10K COTS. And after this, we're going to have a little bit of a pause between salvos, and in which case we can talk about the flights that have launched and who's going to be launching next.
It's just amazed me. We have teams from all continents but Africa.
Oh, wow.
This one, except Antarctica. Of course, there are universities in Antarctica yet. So.
Yep.
But other than that, we have Australia, people from Australia, from Asia, from South America, North America. It's Europe. A lot of European teams. It just boggles my mind how these people come from all over the world to
Participate
and it's
in
not.
this.
And we have a few Brazilian teams, a few Australian teams.
Quite a few Turkish teams
Turkish,
this year.
a lot of Turkish teams too. Yeah, Turkey has that wonderful Technofest.
Yes, so
It's a huge
huge
event.
Rocket Fest.
Yep.
And
So this is truly international. You can say
very international.
Yep.
And the students work together so well. So I've seen plenty of students from teams needing parts and helping each other
Sure,
out.
that's
which is
very
wonderful.
typical here. I think that one of the best things is for example, I'm the hybrids judge, so all the teams of the hybrids, I saw them. We were at the Horseshoe, and out here, they're all interacting and talking, and they're exchanging ideas. It's a very good place to find out what are you doing different than me. And people like to see that, and I've seen many people take ideas home with them to modify or add something.
Which is wonderful.
It's a very useful place to build a network.
Yeah. And it's fun because I found this year judging, I am so invested in the teams I've judged,
Yeah,
where
that's
I
true.
really want them to
you
succeed.
You root for them. You're not
yeah.
supposed to root for them, but you are. You
Yeah,
do.
I
It's
think
like-
you can be fair in the competition, but still have your heart
Yeah.
heart in their success. And this is such a competition where it is a competition, but the teams want to do well, but they also want everyone else to do well,
That's
which
very
is
true.
such a friendly
Teams are very
environment.
supportive of each other like
Yeah.
that. So it's and you can see it right out here right about 30 yards from us right now. All the teams sit and watch where they watch everything going on, and that's always fun to see. And they're always supportive of each other. No, I've never heard a word about trash talk like you would like on a baseball or football game. These kids are all very supportive of each other.
Yeah,
and that's great to see.
They're always excited about each other. So like there's some of the teams are constantly doing well, and then the newer teams are excited to meet them.
Yeah.
They're excited to share ideas. It's really quite wonderful.
And one thing, when something goes wrong, I've seen a lot of other people come up and console them when something doesn't work right. And it's oh yeah, I bet So it's a very very connected group.
Yeah, I remember last year seeing the 5500. There was quite a few Katos with that motor. It
Yeah.
seemed. And you got to be very careful with the building the motor process. So.
Those are expensive motors too.
They are.
That's why I've never launched anything that big. Because I don't know, $800 shoot a rocket.
Yeah.
That's why I like liquids. They're a lot cheaper.
Nice. Yeah.
Hybrid. In fact, the hybrid guys always say, yeah, we can fly an M hybrid. The first time more expensive, but after that, it's way cheaper for a hybrid. So
Okay,
that's why
good to know.
There's some pushing. Yes, that's what the marketing contrails folks talk about. How the cost is so much better on a hybrid.
So each of these teams, in order to build their rockets, They not only have, people at their school who might be giving them advice or mentorship, but they also have a flyer of record. So someone who has their L3 certification, which means that they have flown a number of increasingly more powerful impulse
rockets. That's right. Now, are you an L? What are you an L2?
I am an L0.
L0. You haven't.
And so I have the line that I've heard from a lot, unfortunately, of faculty mentors of I'm going to get my L1 someday.
All right, good.
But let's see next year if I could be held to that.
Now, I was surprised so many schools have L1 programs for their freshmen.
For their freshmen.
For their freshmen, so that it's a device they use, a way to get people interested in it. So you get in, they teach a class, and these are the seniors and juniors teaching these classes to the freshmen, and they go out and fly.
So Rowan University's AIAA club, they unfortunately might have a little bit of a hold, so we will keep you informed on that. But so my school's AIAA club, they have an L1 workshop that they've started. I know that University of Maryland does that to get their L1 and L2s, and so the students at my school are trying to
About
follow
half the
that track.
schools I talked to, the hybrids, I asked them that. Half of them had, and in fact, a lot of them who were like juniors and seniors started at the L1 level. So that was, in fact, at my university, UVA, I'll say if you want to do an L1, I'll pay for your motor.
Yeah.
So yeah, I think it's a great way to get people into the hobby, get people interested in and understand a lot of the technology, what's going on in this, because the students here will be the people who will be the engineering for the big arrows, the SpaceXs, the Blues, the Rocket Labs. All those folks will be working for them, and they're getting right here this practical experience.
So checking on the chat.
Is that Portuguese? I don't read Portuguese.
Oh, I'm not sure.
Or Spanish.
So Zul 7171. So I see some Spanish, I think.
My wife says she's a Spanish major, so she'd be able to.
Yeah, we are waiting on New Mexico. We've got a little bit of a hold. And then I think that and Houston might be the last two in the Salvo.
Duke was
up.
Oh, Duke, yeah.
And his 400 would probably be SRAD 30?
Yeah.
Or, SRAD 30.
So the people have built their own engines, and that's, to do that you need to have, typically they all have mentors that show them how to do it. Now some schools have done it long enough that they're doing it, they have their own setup, and they have, some of these kids have 35 to 5. I don't know if you can see it. We didn't have this table earlier in the day. It makes life a lot easier.
Yes, so I remember we had the iPad on a little stand, but right now the iPad is not working. So we actually do not have any visual. So let me just ask, we no longer have visual here. If we could have some audio feedback on how the flights are going, that would be wonderful.
Okay.
So we are now waiting for 403, Duke University on Delta 2 for the pad. We also had a successful launch with University of New Mexico just before that. We had some technical difficulties, which is why the voice dropped out. So Duke University is flying a SRAD motor at 30,000 feet.
Means they build it, and that's a big motor.
It's a big motor, I can imagine.
Motor. Hybrids are launching, I've been told. All right, well, I'm a hybrids judge, so I'll be in here commentating on it. That's good.
That's fantastic. I can't wait to hear your insights.
Yeah. Well, the hybrids are basically all flying with nitrous. There's University of Sydney, and when I left an hour ago, the University of Sydney and Texas A&M were putting their rockets on the rails, so we'll see who goes first.
Nice.
They also think they have to chill their nitrous, because the density of nitrous changes. If you load it hot, you won't get as much density. You won't get as much propellant or oxidizer inside. So they chill it. Basically, they have a room and they chill it with ice. Some of them, I've been told the hybrids are running. So the whole purpose of that, chilling the nitrous oxide down, is to increase the density. Now the other issue is they're all when they load, they have to find out how much they put in. So both of these schools have load cells on the bottom of their rail, and the rocket sits on that. So they have, and some schools have 2 or 3 ways of determining mass, because it's always been a problem with these bigger hybrids, is that if you don't get a good load.
Oh, 403 just had a
403.
launch. So congrats to Duke University.
Duke University, they're on their way to 30,000 feet. So Duke should be, that's going to be about a 7 to 10 second burn to go to 30,000. So that's, and dynamic pressures are a lot higher too on those in the 10K.
Yeah, so then they have to consider how separation. They might need to use compressed CO2 instead of black powder for separation.
30K caught. They just announced there's going to be another 30K COTS.
For 222, and that is Oklahoma State University.
Oklahoma State University flying a COTS 30K, which means that's a commercial. That's probably another O motor, very large motor, very expensive motor.
I did see some M's in the 30K for
oh,
smaller,
were they? Okay, if you build
motors.
a small
Yep.
diameter engine, yeah, you can get away with a smaller motor. Typically, you have on a 30K COTS using an M, you'll have like a 4-inch diameter. The body tube won't be much bigger than the engine, and it won't be as tall.
Yeah.
So the big 30K ones, like the O motors, those are much taller. So.
Yeah, there's definitely a wide range of rocket sizes.
And they'll design it. They'll look at, say, well, what are the aerodynamics? Keep the drag down as much as you can. Keep the stability at the proper pace. Oklahoma State is up. Haven't heard anything about them. Okay.
And so that is the last of the 200s, which means that there are 21 teams, or at least 21 teams who started at this 30K COTS level. But right now, some of them didn't quite make it to competition, which can happen due to funding, due to various reasons. So we see a little dust cloud out there.
Yeah, we were out at the hybrids pad. There were a lot of dust devils that came up.
Okay, so unfortunately we are not getting feed on the main LCO, and so our launch...
I'm sorry.
That's fine.
That's embarrassing.
No worries.
Just move the table. What an embarrassment.
So, unfortunately, we're not hearing the announcer too. We've heard that you guys are not hearing the announcer, and that is the same for us. But that sounded like it was a successful launch for Oklahoma State University. Okay, it's going down.
Oklahoma State apparently appears to be undershoot.
They see a drogue, which is that first parachute that comes out, and then we're going to wait for the main, which is the larger parachute that you need to reach and land safely.
Mains run about something like anywhere 100 to 100 and
Drogue might not have come out.
That means it didn't separate or something, that, and the recovery system failed. So it was.
Yep. So that's called a ballistic landing because the rocket hits at a high level.
High level speed and it buries itself in the sand.
Yeah, so it's, you know, it still takes a lot to get that successful launch. It's still a win for the students, but can also be a little bit of a heartbreak too because they have a lot of rebuilding for next year.
That's right. Yeah, it came in very fast. I tell the students that this is just like golf. You drive for show, but you putt for dough. So your recovery team should be at least as big as your propellant team.
Yeah.
Because that's where the teams win or lose because the recovery system works.
Yep.
And that's a very key thing. Speaking as an ex-paratrooper, I wanted my parachute to open.
Yes.
And they all did, thank God. So yeah, so the recovery system is I would argue more challenging, particularly some of these high speed ones than the propellant system.
I can imagine because they're working with soft materials, flexible materials. You want to make sure that nothing tangles, that the black powder or the separation occur at the compressed CO2 can cause the main body to separate, allowing the drogue to come out, allowing the main to come out. And if you don't have that happening, there's two types of errors. So one can be that everything comes out too early, which is main at apogee, and that might, if there is, sorry, again, having voices in my ears, it's a little hard to focus on my train of thought. So if there's main at apogee, then that's, a error where the rocket can go quite a ways far away. Do you know what the maximum distance a rocket has been from launch?
Oh, for here, they've drifted 3 and 4 miles.
Yeah, it's quite a ways.
Yeah, they found. Interestingly enough, some of the ones that did drift away found it, and I understand they have found parts. People have been out here, and they'll find different parts that they'll bring back. So that's not unusual either. So it's,
Jessica was saying earlier that the drone team found a fin from last year's competition.
Yes, that happened. That's not unusual. There'll be a piece and nobody will see it, and suddenly somebody else will find it. That's the.
So someone's. Oh, we're going to hybrids now. It's going to be the next one.
That's. I believe that would be University of Sydney is on the rail. Their rocket is called the. I don't want to butcher this word. It's a gaunt, but it's a bird, an Australian bird. They named it after an Australian bird. I hate to ruin the what the name of it is, but
nice.
It's.
If you know the University of Sydney's bird, the gaunt, you could.
It's a small bird somewhere in Australia.
Okay.
So it's and it's pink. So their rocket has a reddish pink coloring scheme, and it's pretty bright, really. They have their rail is set up. It has 4 guide wires. They had a crank to crank it up. I was out there when they did that.
Do they adjust where they aim it based off of the wind?
A little bit. That's vertical.
Okay.
So it's.
It just looks like it's a little bit off.
Sometimes they'll adjust it a little bit depending on the wind, but basically the nitrous tanks are out there too. So those have probably been chilled in the last hour, and right beside them, if you look and see, there are going to be a lot of other. Those other rails are for the other teams. So so once they fire, all the other teams have to pull back to the fallback area, and that's where they launch from. So on all the controls, the difference between this solids and the hybrids is the solids are shot from right outside our door. That's where the launch control officer fires them. These have to be fired from their own. Each team has their own control system, and that's how they can load propellant or load the oxidizer. That's how they shut things down, vents it, and then they do the initial firing. So that's a big difference, and it's a lot more complex. It's a lot more work to get all that plumbing to work with, and you also have to have it cleaned. All the oxidizers are notorious for getting contamination, starting fires, and blowing up. So to mitigate that, you have to make sure everything is cleaned to a certain standard. And that standard is basically, each country, the United States has 2 or 3 standards. Europeans have their own. I'm certain the Australians use probably the European standard. But those standards tell you how, basically tell you what, they don't tell you how to do it, they tell you what needs to be done in terms of process. Like everyone starts with a mechanical process, cleaning. Then you go with sometimes a chemical process. And then you have to do a proper rinsing to make sure everything's rinsed off. Then at the end, you have to test to see is it clean, and there are various test methods you use. So it's a quite a lot of work to get it. I've done lots of lock cleaning or cleaning for oxidizers, and it's something you have to be careful about. It's
Oh, if you could talk into the microphone.
you
a
have to
little bit more.
practice it. You have to practice it. That's one thing I've always done, and whenever we have teams doing that, you rehearse it once or twice. And it's not a one-person event. You have to have I'd say 3 to 4 people working on it, because 2 people are clean and gloves. Typically 2 or 3 other people are out helping, because you always need to get something. Well, someone gets it for you. So it's a complex process, but the school, and that's professional. That's what the professionals do too. So anyone using liquid oxygen, they clean the almost identical way. So that's what's good looks on their resume. I've cleaned oxidizers.
That's pretty impressive. Do you know what heights the hybrid teams
The
are?
hybrids are
launching?
going to 10K. I would have to look. One of them is at 10. Most of them are 10K, and one of them's 30K, and I forget which one is which. What's Sydney? Wish I had my book here.
So
University of
higher.
Sydney. They're going to be a 700, and all the 700s are hybrids.
University of Sydney is 708.
708. So I think they're going to. I think there are 10K COTS.
Okay.
Or 10K SRAD.
SRAD. Because are there any COTS for
not
hybrid?
Yes, there are, but they aren't. In fact, I guess we have one team. Oh, I forget which team it was. It actually has I think Cornell has a COTS a COTS hybrid motor made by Contrails.
Oh.
So there are but they're flying into the hybrid category. So it's
Yep. So they're clearing solids right now, which means they'll be getting ready for that next batch of solids later today.
And by the way, we'll be flying. We flying till later on today. We'll probably fly until 7.
They said flying till sundown. I heard.
Till sundown. Okay, well
Yeah.
that's around here. That's like 8:30.
Okay. Up north in summer, you get sundown happens at like 9:30.
Yeah,
so.
yeah, I know. Yeah.
Okay. But you don't want it to be too dark when leaving on this dirt road.
So the hybrids, you'll know that they've pulled back when you look at the hybrid picture, and there aren't any cars there. That means they've all pulled back.
Yeah.
They've gone to what they call red flag. That means the flag means they're ready to pull back and begin operations.
Yeah. And so some of the other hybrid teams are
There's, for
Arizona State. We've got Cornell, Indian Institute of Technology, Madras.
They didn't make it.
Oh, okay.
Okay. And Iowa State decided they were going to be hybrid. Now they're a solid. University of Calgary, University of Buffalo, Cornell, RMIT, which is the Royal Melbourne Institute of Technology in Melbourne, Australia. We have St. Louis University in St. Louis, Sydney. Notice we have 2 hybrids from Australia, and finally Texas A&M right up here in College Station.
And they're going to the 30,000 for Texas A&M.
Yes. So yeah, they're all. And that Texas A&M rocket is very long too. I was out looking at it. It's like probably 10 foot tall.
Yeah.
So interestingly, a lot of these schools weigh their rocket. There's a load cell on the test stand, or on the on the launch rail, and when they slide the rocket down, the rocket's sitting right on that. And the way they can tell when they load nitrous is they literally weigh the rocket, and they know how much. Let's say you're going to put 15 pounds of nitrous. It goes into the rocket, weighs right now 80 pounds. When you're done, it ought to weigh 95 pounds. So that's how you guarantee that you've got a LOX, or not a LOX, I'm sorry, wrong oxide, a nitrous load that's safe. Because there are many legends in IREC about people that didn't get a good load and what happened. So that's why there's a strong rules about how you can prove you have a good load.
So we have a lot of fans of hybrids in the chat. And again, So one of the common questions on the chat is the order of teams posted anywhere? And no, because during the competition, sometimes things will come up where the students will need to adjust something on their motors. They might need to come back, recharge some of their computers for telemetry. So things can change so often that we're usually finding out as we're going through who is launching. So there'll be a group of students on the servo for each of the servos that they have out, but we usually learn that a little bit later of who is in those servos.
It's interesting. I was talking to the folks from RMIT, and they sent us 700-pound shipping box via. I guess it got flown here, and they delivered it right here to Midland. So that's how they got their equipment. Calgary have two of their trucks down from where Calgary is in I think Saskatchewan. They drove down here. Like it took them a couple days to get down here. So
yeah.
It's amazing all the schools that are Sydney and our RMIT shipped everything there. So it's a lot of work.
It's quite an effort.
Texas A&M, where the closest College Station's wide. It can't be more than 3 or 4 hours from here. But that's that's the closest university.
So while we're waiting, someone asked who has launched. So Universiti Teknologi Malaysia had an attempt, which unfortunately was a Cato. We had Instituto Tecnologi de Buenos Aires, and they had a successful launch. The students are real happy about that. ETS launched.
ETS is in Montreal.
I'm
ETS
unsure.
is one of the Canadian schools. It's
okay.
It's École technical supérieure.
Yep.
And they're in Montreal, Quebec.
And a couple of these notes, I'm not sure if they are certain, but I think University of Washington Seattle launched.
Mm-hmm.
And we also had Worcester, Brigham Young. They
BYU had a hard landing.
Yeah, they had a hard landing. They had a successful launch, but again, that recovery can be very tough.
Mm-hmm. Mm-hmm.
And then earlier today, after the wind hold ended, we had University of Louisville, Kent State, Purdue, University of Minnesota Duluth, Virginia Tech, University of New Mexico, Penn State, Carleton.
Did Houston go?
I don't think Houston went.
Okay.
And we had WPI, we had Michigan State.
Oh, Michigan State, okay.
Yep. And we had University of Texas El Paso, we had Universidad de Antioquia, and Embry-Riddle Prescott, and Texas Test, and Duke University.
Okay.
And Oklahoma State as well.
Oklahoma State. So that's
so those are the ones who have launched, and
that's about 15% of maybe 12% of the rockets so far. So we have 106, 140 teams here. I can't remember how many teams we have.
I've heard something along that line.
Mm-hmm.
So 140 teams.
Yeah, we've got another 80, 90 teams to do, 100 teams to do.
Yep.
So it should be a busy next 3 days.
BYU did launch, so and it says WVU did, which was mistaken for BYU earlier this morning. I don't think that's true. Do you know if West Virginia launched?
I do not know.
Okay.
I have to ask. It looks like 7:05, and they are RMIT have decided they are on the rail.
Yep. See their tent. Very impressive.
Mm-hmm. They have a very impressive load system. So what they'll do is they'll prepare all that.
So make sure to speak in the microphone.
Right, they'll prepare all their equipment, get it all set up, plug everything in, then they pull back, and all their controlling is done 1,100 or 1,200 feet away. So that's, if you look at all, it's very intense. It's amazing to see all the hardware that they go. In fact, I'll give a call to Swagelok for being some of the sponsors for these teams. Swagelok is a very useful. I've used Swagelok for years, and it's you can rely on it. It works very well. It seals excellent. It's an excellent sealer. The fittings are great, and you can typically get them in all kinds of sizes too. Very numerous. You look at their catalog; they have a lot of different configurations. So, I have used Swage Lock quite a lot in rocketry, and then they're good. In fact, there's a story I heard. The Swage Lock president has in his office a picture of an astronaut doing EVA, and they have a Swage Lock part on that picture. And the interesting thing was, Swage Lock never certified it for space. So NASA the contractors got it and certified it. So that was a piece of Swage Lock in space.
That's
so
fantastic.
that's the kind of quality those guys have. And I'm a great Swage Lock user. I have it on my own rockets, on my own test stands. I have Swage Lock. So.
And so we're seeing some questions in the chat of different teams. So I think if it wasn't a team that we said, they probably have not launched yet.
Okay, one of the big problems with the hybrid guys is, of course, the tanks they're in, these big bottles, steel bottles, and they're pretty heavy to move around. So you have to have carts to move them around, and you want to cover them up so you try to keep the temperature down. So that's always a big problem out here at the IREC is. It's just hot. So it's
Yep.
Yeah. People that fly hybrids in the winter don't have these problems.
Any chance that we'll be doing IREC in the winter?
Oh, probably
some year?
not.
Yeah.
Probably not. In the
Students
Christmas
are a little
holidays,
busy.
I don't know if anyone wants to come out here for Christmas holidays.
Yep.
So.
And so a question is 10K COTS done? It is done for that Salvo. So
There are plenty of 10K COTS teams
plenty
left.
of 10K COTS teams. That is the most popular category. So we have, looking at the numbers, 102, 104. So we had over 100 teams sign up for 10K COTS at the
that's a
start
lot.
of the
And
year.
we fired, about 10 of them so far? 10, how many number 10K COTS? 1, 2, 3, 4, 5, and then 5. We probably have about 10 shots of 10K COTS, so we've got 90 more to do.
Yep.
And the reason people do 10K COTS is it's relatively, I'll use the word easy, but that's a sort of a stage factor.
Attainable.
It's obtainable, and it's fairly relatively inexpensive compared to an O motor. So those are all. That's why it's always good to start at a smaller level. So teams will get into this and they'll say it may take them 18 months to 2 years to get their first rocket built, and then it takes. I've talked to lots of teams where the seniors start as freshmen on some of these projects. So it's an investment in time.
Yeah. Another thing that's nice about the 10K is there's a lot of room for creativity where
That's
students
right.
can find ways to make the rocket their own.
Has your school fired yet?
No, they're in the next Salvo.
The next Salvo. All
They're in the
right.
next, so I'm going to be stepping
and
off.
they're 10K COTS, right?
They're 10K COTS,
Okay,
and I'll be
and you're
stepping
gonna
off the
step
mic
out,
for that.
right? All
just
right,
'cause
good.
I'd rather hang out with them.
I
This is a
appreciate
lot of
that.
fun, but
I know
yeah.
what you mean. That's okay. That's you're their advisor. That's where you should be with
Yep.
them when they shoot.
I'm so proud of them. But so right now people are asking what's going on at the pads. So it looks like the hybrids are still setting up. Do you know how long this process usually takes?
It can take. It shouldn't take. They've already set up. The question I don't know is what the state of their oxidizer is, how cold it is. So that's once it's chilled down, then they're ready to go. And it looks like they're still out there, but a lot of people have pulled back, so they're obviously getting serious. So it could be another, what is it? It could be easily another 45 minutes to an hour for the COTS folks. Now the advantage you have is the COTS teams are the 10K teams are enough distance from the hybrids that they can operate where they fly and the hybrids can keep working.
Okay.
And vice versa. So if you have a bunch of people with the 10K COTS pads, the A and B pads, the hybrid guys can fly.
Oh, so we probably have the other Salvo
Right.
getting ready right
That's
now.
right.
Oh, that's great. And so it looks like people are heading towards their trucks, which you said was
Yep.
the sign that they are getting
They're
ready.
getting their trucks and they're going to. That means it's time to pull back.
Yep.
Then the last guy who'll be on the pad will be the pad manager. It's Paul Holmes.
Paul
As the pad
Holmes.
manager, Paul's a well-known man in the hybrid business and for Tripoli, and that's why he's out there. I think he's one of the best guys for the job. He's tested all the Tripoli commercial engines, that are hybrids. So he has a lot of experience in that. So, and he's built a few of his own. So,
Nice.
man has done great things.
So one thing I've heard is that this team has some live video or telemetry or possibly both. And oh, sorry.
they don't have
Hybrids
live
do
feed.
not have live feed. So it's
No
going to be
live feed in
solids will have
hybrid.
live
Okay.
feed, which is a bit more convenient because I think it might be a bit more challenging to get them. So for the live feed here, we have students with their computers here, but as you said, the students for hybrids you have to have a couple down there. I guess you could have some here with their ground stations.
And I believe we should be able to see the hybrids launch. We have cameras out there, so they can actually see, and the drones will be out there too. So we should be able to get a good view of a hybrid launch.
And the question is, when will the next Salvo start launching? And it will start launching when it starts launching. So that's always a little bit of news to us, just because they want to have all the students. So it's about 16 to 18 teams that might set up their rockets. They need to turn on all of the electronics. They need to arm their motors and get them ready for launch. And then all the students need to leave so that there's plenty of distance between the students and the rockets before launch.
And then the students also set up all their typically telemetries and things like that. Their Yagi antennas they got set up, and they're all actually that's all going on right out behind us here.
Yeah.
So they have students will set their tables up. You'll see the guys out with the Yagi antenna, which is an antenna that's a directional antenna. Rowan, you were
Yeah, so someone said they're really excited that they can hear me. So that's very sweet to hear.
Okay.
And so we are on, this will be Salvo 3. So hybrids, since they have their own launch site, do they count in the Salvo descriptions? Or are they
I don't know how they're going to do it. Yeah, it's probably a close.
So hybrids 2.5 and then hybrid Salvo 3 will be going today. And I heard possibly 5 or 6 Salvos today.
Possibly. I mean, we have enough time. If we do this until 9:30, 9 o'clock, we could probably get another Salvo after this one.
Yeah.
Certainly in the solids. If the hybrids go, there's only 2 hybrids ready to go.
Yeah.
So that'll be those 2 go. That'll be it.
Okay, hybrids just went green for continuality.
Oh, okay. Hybrids are green. That means they went to. You said solids went or hybrids went green. Okay, we're trying to get confirmation about the flag system. Let me explain the flag system to our audience. The green flag means everything's safe. You can come and go. The yellow flag means we're preparing. So that's a warning. And red flag means once you go red flag, everyone pulls back and you're ready to start operations. So here, once red flag would go, teams would begin to load propellant, and you'd have when you pull back, all your electronics are turned on. You pull all your removed from flight keys, and you've tested it and you said we're ready to go. So you pull off the pad, and that's in my mind that's always a commitment.
Yep.
Another commitment is when you begin loading. Everyone has their checklist, and they say, all right, we're at the point to load nitrous. Now that's a big commitment because the nitrous has to go somewhere.
Yep.
So typically you like to have it shoot.
And
once you load nitrous, you also typically have some issues about it's going to start to warm up. So there's you have a time. You just can't sit hybrid vehicle can't sit out here the way the solids can.
Yeah.
Because they will boil off. So that's the other issue. So when you do it, it's a commitment.
Yes. Okay, so one of the rockets is red, but they are still filling for one, and Texas A&M might be launching.
Okay.
Is what we're hearing.
The red one is RMIT.
We definitely saw RMIT on the cameras.
There's someone's red flag.
Okay.
There's some. The hybrids are red flag.
Hybrids are red flags, and
So what that means is once they all pull back to their faraway state or their pullback station, they begin operations. And already all the teams have tested all their equipment, so they know that they're ready. That they're at the point to where there's a fill commitment. So once someone, they'll get their fill. They'll say, "Can we load?" And they'll talk to the range safety officer and the pad manager, and they'll say, "We're ready to load." Range safety officer will say, "Go," and they load, and that's the commitment. And we know they're going to have to do something in 10 or 15 minutes. They have to, it's a short time. Loading typically can take anywhere from 5 to 10 minutes. 30K hybrid's going, okay? That's, I think Texas A&M is a 30K hybrid. And then so a lot of the drone pictures showing everyone's pulled back. The hybrid pads are ready to go.
So that's definitely RMIT over there. Oh, both hybrids are a scrub.
Oh, okay.
That's what they
just
said.
News. Both hybrids have scrubbed, and I'd like to know why, but that's part of the business. So
you said that's rare for hybrids?
That means they haven't. I don't think if they scrubbed, they probably didn't load.
Okay.
So for whatever reason, both hybrids said it's not today. So that's part of the business. Then I would also remind us all that that's happened in the professional rocketry all the time. SpaceX and Blue Origin sometimes goes to the pad and they don't launch.
Yep.
So that's part of the business.
And not launching doesn't typically make the news as much as launching
Right,
when it's the wrong choice.
Exactly.
So it's a good, smart choice on the behalf of the students.
And if it isn't the right time to do it, they say we're not going to do it today. I applaud them for their decision.
Yeah.
Because a lot of times people get they call it the go fever. And you don't want, that's happened, I've seen that more than in aviation and in rocketry. So you have to fight that.
Yep. But speaking about the heat, so as a comparison, a lot of the last Salvo and the Salvo that we're waiting on for Salvo 3, they were out for hours in the hot sun.
Yes.
So you see a lot of rockets are covered in Mylar blankets to protect them from the heat.
The solar, you want to try to mitigate the solar radiation. The Mylar blankets do just that. Yeah.
Especially if you have a team that's silly enough to paint their rocket black.
Yeah, that's.
So
hybrids are shut down or scrubbed for at least, I guess, I don't know. I'd like to find out why they scrubbed, but it's both of them simultaneously scrubbed. So maybe it was another problem.
Yeah, someone suggested too hot for hybrids, and I think that is a very very educated guess. And
because if they didn't get enough time to chill their oxidized, their nitrous, then they wouldn't have the density. They wouldn't get the load.
Yep. So maybe tomorrow afternoon or Friday, because tomorrow morning we might get some window.
Yeah,
some
might
wind.
be bad. Yeah, might be bad. So. So I guess we're going to move over to our other Salvo. Is that what we have, B-rail or the B?
Salvo 3. So this
Salvo
would be
3?
the last bit of our sunrise flights at 6:26.
Okay.
So the students might have been ready to fly at 12 hours ago, but you know what? It's exciting. They're all probably thrilled to be here.
Yeah. Yeah, too hot for hybrids. Yeah, I can appreciate that.
And you say how the winds tomorrow afternoon? You have better internet than we do, so feel free to do a weather check
if someone wants
and
to
let
do
us
a weather
know.
check about the Pecos Sargasso, what's the little town just south of here? S-A-R-A-G.
I was just told and I instantly forgot, so I apologize.
So there's two little towns. We're about 30 miles south of Pecos, Texas, so that's what the wind's going to be like tomorrow.
Yep.
And it will be 100 and probably another 105 day.
So here you see the students at the pads, and
lots of people out there busy.
Lots of people out there, and it's kind of at an angle, but I believe I see Rowan University students.
Oh, good.
So I think that's them, but I'm not 100% sure. Because I don't. Oh, yeah, there's that black and gold rocket.
Oh,
so
the black and gold. Is that the school
that's why we
color?
had Mylar blankets.
Okay.
So.
Oh, it's Mylar blanket. Oh, all right.
Because they had a black rocket.
Oh, okay.
for their night owl.
Oh, the night owl. Okay,
Yep.
I saw they have a T-shirt. That says, yeah.
And let's see if we can see who else is launching. So, fortunately, it's a little bit small, so hard to read who else is out there. Hopefully, we'll hear soon.
We should be getting word from soon. Well, that's another interesting design problem because these students know when they design their rockets, it's going to be hot.
Oh yeah, and so
So-
that's why they planned. So they made sure to get their flight safety review on Monday because their flyer of record was working here on Tuesday. So they made sure to get everything done early. They woke up, I think they said 2:45 this morning.
Sure.
But the weather, it's a little chaotic, and
Yeah, someone told me there's a storm off and somewhere in the Gulf right now, and that's not helping the wind.
oh, I can imagine. We have a carrying fan of Florida Atlantic University. I haven't heard anything, but hopefully that is as soon as we know who's on the Salvo, we will let you see. So, and because I think some of the other teams that I judged are also. So some of the teams that I launched, because I think okay, so I recognize the team that's on site, and it's between one of two universities because I judged them. Very, very great team. And someone in the chat.
Yeah, if our team if you guys can get some team name numbers down, we would like to have them.
So hopefully we will get that information for
Yep.
you. We just requested it.
Okay.
Oh, wonderful. Okay, so West Virginia University was the first team to launch today. So they have launched
Okay. Oh, yeah, that's it. Number one.
number one. So congratulations to West Virginia University for being number one. And Brigham Young also launched a bit later because I remember commentating for that. So
So the drone's flying over and taking pictures of a lot of the different people sitting around. There's a huge student spectator area right outside of where we're at, and that's where all the students congregate to watch. Okay. Okay, well, so let's go through and let everybody know who has launched. As we said, Washington's, say again?
oh, pull your mic up. So
Oh, mic up. Okay, mic up, please. University of West Virginia. At I think they're in Morgantown. I've been through it a few
Yeah,
times. Have
gorgeous
flown.
town.
Number one. We saw Louisville, University of Louisville, which is in Kentucky, northern Kentucky on the Ohio River. Kent State, which is up in northeastern. They've flown northeastern Ohio. Purdue, central Indiana. University of Minnesota, Duluth. Virginia Tech, and Virginia Tech's in the eastern side of the state. University of Houston.
I don't think we saw Houston yet.
Oh, Houston hasn't
They
flown.
were,
Okay, I'm sorry. Okay, University of New Mexico's flown. Penn State flew. Carleton flew. Worcester Polytechnic Institute flew. Michigan State, University of Texas, El Paso. That's how you pronounce that? That's
am
Portuguese.
unfortunately not, sir. Universidad de Antioquia.
Antioquia. I believe that's they're Brazilian. Embry-Riddle Prescott. Oklahoma State University, Texas Tech, and Duke, the ones we have now. Who flew over here?
In the morning, we had Universiti Teknologi Malaysia. We had the Institute of Technology of Buenos Aires. We had ETS, so my French is awful.
Okay,
Would you like
École de Technical Supérieure, and they're in Montreal.
Yep. I see a dot near University of Minnesota Twin Cities,
City.
but
I'm assuming they, and then University of Washington Seattle flew too.
yeah. So
Okay,
Washington,
and I
Seattle.
believe Liberty flew. I have notes that Liberty flew.
Yep.
And Brigham Young University flew but had a hard landing.
Yep.
So that's the cap for the what we've flown so far. They're reloading right now out on the, I believe, the 2 solids pads, so we'll be getting a lot of solids. And we've got plenty of daylight left. We got 3 hours of daylight left, so it's possible.
Yeah.
And the wind seems to have subsided a little bit, so that's good too. Okay, that's a
And so, oh no, my phone is very much dead because we are all. It's because I had the list of all the people who were approved for Sunrise Salvo.
Oh,
So we
okay.
could have talked about that because that's some of the potential people who we might be seeing on the Salvo. And so a lot of students I talked to said that they wanted to launch today at Sunrise, and a lot of them were ready to, but Texas wasn't ready for them.
Yep.
So
That happens a lot in the rocketry business. You can be ready, and something that you can't control changes.
yeah, University of Minnesota Twin Cities did not go yet, but University of Minnesota Duluth
did.
went.
Mhm.
So that is correct.
And I
And
believe
Antioquia is from Colombia.
Columbia, I'm sorry.
Thank you.
Okay,
Appreciate
thank you.
that feedback. And we're going to be heading out soon and shifting off to someone new. But thank you for listening to us, and good luck to the next batch of teams.
Okay.
And yeah, go
IREC.
Profs.
Go IREC. Okay.
Go IREC too.
again, I wanted to update you as they are getting ready to put out Salvo 3. So the first team up is going to be Team 84, Northwestern. Second should be Team 216, Mississippi State. Third should be Team 3, Kennesaw State. 4 should be 93, Team 93, South Dakota State. Hold just. All right, so going back, number 4 is Team 93, South Dakota State. Team 5 is going to be Team 204, University of North Dakota. Six is going to be Team 215, Eastern Washington University. 7 is going to be Team 59, Rochester Institute of Technology. They are going to attempt live video. 8 is going to be Team 83. Sorry, I'm just checking my team name. Rowan University. Nine is going to be Team 81. And that is going to be Clarkson University. 10 is going to be Team 90, University of Pennsylvania. 11 is going to be Team 72, Utah State University. 12 is going to be Team 204, Toronto Metropolitan University. Team 38 is 13, and that's the University of Georgia. 14 is going to be Team 102, that's the University of California, Santa Cruz. 15 is going to be Team 317, George Washington University. 16 is going to be Team 98. They are attempting live video, and that's the University of Tulsa. And 17 is going to be Team 30, Lehigh University. Just to give you guys an update. And also a reminder to please drink water if you are on site. Stay hydrated.
Is it turned on? Okay, hi. Welcome back. We are here. We have the third salvo of the day here at the International Rocket Engineering Competition. Jessica, can you come in here, please? Live engineering. And the salvo up is a good combination. Is it dead?
No, they've cut your audio, so you're good.
Oh, okay. So give us a call. Give us a comment. All right, we're live again. International Rocket Engineering Competition at the third salvo. We've got a pretty good lineup for us today. I'll just rattle off what's on the schedule. Up first would be Team 84 Northwestern, followed by Team 216 Mississippi State. Next team would be Kennesaw State, followed by okay, which one's is flying?
Looks like they're flying the drone out to Team 803 Akron right now.
803.
They're talking about the demo 45K.
Oh,
flights
the
right
45K demo. Akron is flying. Is that a single stage or two stager?
I am unfamiliar with what it is going to be right now.
Okay.
But we know that the big waiver was called in, so.
So the waiver for the FAA was called in, and we are Akron's going to fly to what altitude?
They're aiming for 45,000.
45,000 feet. Okay.
So it should be Akron and I believe Johns Hopkins are
okay, and Johns Hopkins
up there and ready to go.
Okay, so they're ready to go. They'll be the first up. Akron is not competing. This is a demo flight. A demo flight is a flight that is it's a flight for record, but it's not going to be judged. But they're going to try to hit 45, which is about the highest we can go here.
That's right. The highest we can go is 50,000. So we're going to step 5% or so back from
5% back
our maximum
okay.
to make sure that we have play nice with the requirements we have from our friends at the FAA. And
Akron is noted for doing a lot of amazing things. For example, they flew the first liquid. They flew a liquid over Lake Erie.
Wow. Okay.
Yeah, out of this area called Sandusky, the northern part of Ohio, and they have a liquids program, and here they're trying for a 45K. So Akron's a pretty aggressive group there. I've met them before, and they work hard.
Wow, fantastic. So you see that red flag there that's shown on the screen right now. We may be a little delayed too.
Yeah.
I apologize for that. But the red flag you see at the pads indicates that the igniters are installed and have continuity. So they are expecting to have launch at any time, or they're ready, certainly ready for launch, and everyone has to leave the area.
Now, this also interesting. We have some teams. We have two teams that will have live video on. So we are about a 30-second delay on looking at our video here. So you may get to see live video coming. So the video will show the rocket coming off, and then the parachute the drogue will eject out, and you'll see the whole sequence of the parachute coming down. And that's interesting. I've been watching two of those today. They're very
Okay, I've been running around all day.
You've been running around, okay.
My job here has mostly been to make sure that the teams, as they prep their rockets, are staying safe.
Oh, good,
so,
good. Yeah.
That's making sure that they're handling their energetics responsibly. They have all their PPE on. They're hydrating. By the way, if you're watching and you're here, go ahead and hydrate right now. It is really hot. It is over 108 degrees out there right now.
So this is a very hot day.
And then I'm also working as a flyer of record. Oh, we got one going off.
One.
Team 803 Akron.
Akron.
We have liftoff.
Lifted off. They're headed to 45,000.
And sustainer ignition.
All right.
We're hearing that from outside.
Beautiful straight boost and straight.
Let's see.
So there are a bunch of happy people from Akron.
Yep. So again, our video feed is delayed. But we can hear everybody celebrating outside the trailer
that's
right
right.
now.
Yep.
So
right outside of a trailer, there's the area where students sat and watch the launches. So
yeah,
you'll hear
we can hear some cheering.
Shout. Yep.
So it is quite the achievement to get your second stage to light. A lot of
okay. I just heard
complicated things have to happen.
That's right. A lot of stuff. I just heard Team 404 Johns Hopkins University is going to make an attempt. Okay, the videos you're seeing with the cameras that you're seeing on live stream are coming out of drones. We have 2 drone pilots out flying their drones, and they are coordinating to get the picture we want, so you can see it.
Okay, we're finally getting the video just now of the flight.
Mm-hmm. So congratulations to Akron. I hope the recovery system works. That's like I say, the recovery system is as important, if not more important, than propulsion.
Right. And you have to do it twice on a 2-stager.
Right. So,
okay, we're seeing the video now, and yep, you can see that little line right there. That's the sustainer.
Okay,
fantastic.
Good. Congratulations to Akron, Team 803. Now they should be shooting the next one. Next one's scheduled. I think I've heard it. They're talking about Team 404 Johns Hopkins.
Right. Yeah. Well, they have the 45K waiver. They need
45K waiver.
Knock both of those flights out. Yeah.
By the way, for those who don't know, a waiver is the FAA giving us permission to go to a certain altitude, because these altitudes are over the jets fly at 25 to 38,000 feet. So we have to integrate ourselves into the national airstream or national airspace.
Okay. We can hear outside they're about to start the countdown live again. So our video is not showing it to us, but we can hear what's going on outside the trailer. So good luck, Johns Hopkins. A lot of hard work goes into one of these flights.
Johns Hopkins is I believe it's in Maryland, not too far from D.C.
All right,
yep.
Here we go. We're counting 404, Johns Hopkins. For the clear sky.
5.
All right. 5, 4, 3, 2, 1.
And we heard the rocket take off.
Lift off.
Yep. So Johns Hopkins is heading to 45,000. Yeah, we were in a wind delay for a long time, so that's what we're trying to catch up now.
Yes, we are. I have not heard a report of the second stage.
Oh, by the way, the Akron team calls themselves the Akronauts.
Okay.
And a lot of people from Akron are congratulating them.
Yep.
Akron
See, we've got some Bulldogs in there as well. Some Brazilian teams, and then the KSU Owls, my old stomping grounds.
Oh, okay. Yeah, Akron has been to I put on a liquids workshop in the spring, and Akron's been to it a couple times.
Wow, okay. So once again, Rick and I are still waiting to get the video. There we go. There's the launch.
There's the launch.
All right.
Okay, it
We're
sounds
seeing
like
the boost.
We've just got word from the people that they're moving the videos equipment or the video drones over to the solids pads, which means there's we're going to start on the solid pad. We'll start probably, I think we have Team 84 Northwestern should be first up. So right now, all these teams have loaded their rockets. They've put their igniters in. They have a red flag on that pad, and they're going to go right down, and they're going to start shooting.
Yep. Okay, so let's go over the teams that are on the pads out there.
Okay, we have Northwestern is on. The way we've gotten it from the people who are running it is that the first 4 teams are going to be Northwestern, Mississippi State, Kennesaw State, and University of North Dakota. So Team 84.
South Dakota. Come on, let's.
No, this one A3, and then we'll go this one, and then we go. South Dakota's Team 5. See, we have that one.
Oh, A5. Okay, I'm sorry.
A5. Yeah. So there's we don't know if it's North Dakota or South Dakota is going to go first, but we have those are the 5 who are on the A pad.
Right. All right, and then Bravo's going to be Eastern Washington, Rochester Institute of Technology. No, they're a scrub.
Scratched.
So RIT is scratched. Rowan University is on B3. Clarkson University is going to be on B4, and they are going to have live video.
Mm-hmm.
And then Charlie 1 is Utah State. Charlie 3 is going to be UGA. Charlie 4 is University of California, Santa Cruz. And then Delta 1 is George Washington. Delta 2 is University of Tulsa. They'll have live video. And then wrapping up is going to be Delta 4, Lehigh University. Now, the Lehigh University rocket has a beautiful vinyl wrap on it. Have you seen it?
No, I haven't.
Oh, it is gorgeous. They did a great job on that rocket. It looks fantastic. Which, as both of us know, is a great way to tempt the rocket gods.
Yeah,
into not getting into something going wrong.
Yeah, that's why when I do my rockets, I'm not that great of a artist or craftsman. I build a rocket and fly it, and I paint it once. That's it. You know, it's. And also because I'm not that good at that stuff. We have some guys in my club who are artists.
Yes.
Oh.
And this looks like it was a mural professionally painted by a painter, not just a body shop, but an actual artist doing, reliefs of campus, views from their campus and stuff. So it looks quite good. And then let's see, do we have anything else going on?
No, after that, the Lehigh, and it's going to be 7, and figure if we get through this in an hour and a half, it'll be 8:30, and sundown is probably about sundown. So the plan is to fly until sundown, trying to make up for the 6 hours we lost because of the winds. So we're hoping the wind gods are gentle today. Tomorrow we found that the winds will be higher than we like.
Right.
So we'll have to see.
So we can see the drone following the main road here, but the pad it's got to go to is off to the left. You can see that little tent right off to the backside over there. So it's got to make a left here. Again, our video is far delayed, so everybody else is in front of us.
And you can see, for those of you who are not in Texas, this is virtually a desert. It's sagebrush, lots of sand. I mean, we walk around here and I feel like I want to brush my teeth because I feel all the grit in my teeth. So it's the wind blowing has made it it's made it rather unpleasant.
Okay, so we can see the drone is starting to approach the pads now. And so the pads are numbered. I know we gave out the assignments along the way. So the way the pad is set up right now, and the way the drone's positioned, is left to right, nearest to the drone is row A, and then moving further back is row B, row C, and row D. So you have 1, 2, 3, and 4 going left to right.
Our first shot at the solid pad. At Alpha 1 is Team 84, Northwestern University.
They're announcing Northwestern right now.
Project Atlas. 10K COTS, F-1350 white.
It's an M1350 white,
Oh,
going
okay.
10K COTS.
Okay, they're setting it up now.
All right. Let's see what we got here.
Northwestern is just north of Chicago, and the
I
school.
believe so.
Yep.
I just visited Chicago a couple months ago.
Oh, all right. Yep.
We have a green light. We have clear sky.
Clear sky, clear range.
Team 84 is going on Alpha 1.
Team 84.
Here we go.
Going in 5, 4, 3, 2, 1. Lift off.
It's taken off. And they're at 10K cots, so they're okay. Apparently, they're having live feed from the team. Has a live video camera they're tracking.
They're calling. They're saying they have drogue out, and I'm hearing some cheers. So
That's a good sign.
yep, LCO's calling. They have an event, so it sounds like they're gonna be down.
Next up is Mississippi State.
All right, next up, we have on Alpha 2, Team 216.
All right, Alpha 2, Team 216, gonna be Mississippi State Bulldogs,
Cowboys. This is a 30K cop.
and they're going for 30K.
30K cots. Okay.
Second, 30,900 feet. So Alpha 2 is hot and green. Skies are clear. We are going in 5, 4,
5, 4, 3, 2, 1.
And ignition.
Ignition. And then Mississippi
Sounds like
State
somebody is happy.
is ringing cowbells as
Yep.
they are wont to do.
Yep.
So
they're happy.
nice to hear some team spirit. Now we're just now seeing the Northwestern live video stream.
Yep. So Northwestern had a drogue out, so it looks like their drogue was pretty successful. Looked like about about 30-inch drogue, you think?
Yeah, it's something like that. Okay.
Next up is Kennesaw Team 3, Kennesaw State on A3, pad A3.
I don't know if they're going to try to squeeze this two-stage in
Okay.
at some point, but it looks like the drone is making a cross-country flight, so I don't know what it's doing in between our shots of the live telemetry. But I think we're just getting the Mississippi State shot now. Oh, okay. They're calling pad A3.
All right, we're going to move on to pad.
So we're about one launch behind right now, I think, on our video.
Right. The video, yeah.
Yeah.
Kennesaw State's on pad A3, Team 3 is up next.